The planet we're used to today was most likely extremely different a billion years ago, was even more different 2 billion years ago, and most likely changed its appearance every once in a while. For example, we know that a few billion years ago, it's quite likely Earth was purple, or at least the oceans made it appear purple. This is usually referred to as the Purple Earth Hypothesis. You can learn more about this in the description below. But during this time, photosynthesis was very likely based on retinol, making the water appear this way. This is from Lake Hillier, one of the pink lakes in Western Australia. Then, about 1.8 billion years ago, Earth experienced a major glaciation period we sometimes refer to as the Snowball Earth. This was actually just one of several such events. During this time, a lot of biosphere on the planet seems to have reset, and once the ice melted and we found ourselves with a new Earth, this began a completely new era. And because of the presence of photosynthetic bacteria that relied on hydrogen sulfide instead of water, and actually produced sulfur instead of oxygen, the color on the planet and the color of the oceans most likely changed once again. Here, some scientists believe it might have even been black, or possessing some other unusual coloration, even making it appear slightly milky instead of blue. And strangely enough, today we believe that Earth remained this way for at least 1 billion years. But we actually know very little about this period. For one simple reason. Not a lot seems to have happened for that 1 billion years. Not a lot of geological activity, no major volcanic eruptions, no powerful impacts or asteroid collisions, and even stranger, the plate tectonics or continents did not change much either. It's as if planet Earth decided to just take a break for 1 billion years. And so when looking at fossils, this is actually one period that we basically know practically nothing about. Today it's known as the boring billion. The strange period on planet Earth where not much seems to have happened, and even the life itself did not seem to change much either. Or at least that's what we used to believe, up until, I guess, the last few years. And, well, hello wonderful person, this is Anton, and today, once again, we're going to be discussing incredible and completely unexpected discoveries about that boring billion. Once again, there's a completely unexpected discovery, and here I think pictures will probably do it justice a little bit more, that in essence show us a ridiculous diversity of life that seems to have existed back then, but that we practically know nothing about. And all of this once again discovered completely by accident. With some of these life forms resembling something out of a science fiction story, not so much anything from modern life. But here there is quite a lot of evidence that this does seem to be somewhat complex life, possibly even similar to modern mushrooms. Or I guess more specifically, fungi. And so let's discuss these two incredible studies and what was discovered so far, and of course let's talk about what this might mean for our understanding of evolution of life on our planet. Okay, that last question is pretty easy to answer. We once again just realized that we know very little about how life evolved and how complex it already seemed to be approximately 1.8 to 1.5 billion years ago. And so even when it comes to trying to understand when some of the more complex cells evolved, there's still a lot of confusion and just not enough evidence to determine anything. But if you've been watching the videos for the last few months, you know that this is not the first video about the so-called boring billion. As a matter of fact, we haven't talked about this topic for many years, and suddenly there are several studies discovering something absolutely incredible about this period. You can find the links in the description, but in a nutshell, there were two major discoveries. First, it was confirmed that the rotation of the planet was approximately 19 hours per day, but intriguingly, it hasn't changed for that whole billion years. This was completely unexpected, but the evidence seems to be there. But second of all, there was evidence for an unusual life or unusual biome that seemed to exist prior to anything that's known to modern science. It's actually completely unknown what this might have looked like, but the signs of this life seem to be there based on molecular analysis. And it seemed to be everywhere on the planet, but was definitely different from any modern life and from any modern cells. Nevertheless, it seemed to be dominating the planet and was probably a large part of the biomass. And it's that last discovery that kind of takes us closer to, well, the big mystery. How exactly did the modern cells form? Eukaryotes are way more complex than bacteria or prokaryotes. But exactly how this evolved compared to this is not a very easy question to answer. Okay, we don't even know how bacteria evolved, but how bacteria then somehow transitioned into eukaryotes is an even bigger mystery. And so, discovering these unusual ancient organisms existing during the Borean billion could provide some of the answers. Maybe this was the transitional stage. But that particular study had an obvious problem. The only evidence was molecular, and no actual fossils were ever found. And that's actually the biggest problem with studying the Borean billion. Because the Earth was so quiet and there was no geological activity, there was also not a lot of fossils. And so we don't actually have a lot of fossils from that period showing us anything. There are fossils of bacteria and there are certain fossils resembling some kind of an algae, but they're extremely rare and generally do not show much. And so up until I guess this point, it was almost impossible to imagine what any of this life would look like. And then we have this new study. And once again, this was discovered completely by accident. The scientists studying this weren't even biologists. From what the scientists described, they were actually studying rocks, specifically beryl and topaz. And here they gathered this from one of the Ukrainian mines that's known to contain quite a lot of different gemstones. This mine is known as the Volyn mine, and this whole discovery is now known as the Volyn biota. But because they were actually studying the structure of these rocks using advanced electron microscopy, they then realized that completely by accident, a lot of these samples seem to also contain strange three-dimensional shapes. Shapes resembling something they've never seen before, and actually resembling what we might describe as some kind of primitive life. With I think this one probably being the coolest, and also being the one that's kind of difficult to explain. With of course the biggest question now being, so is this what that life looked like? Is this the life that was just described in that other study from just a few months ago? And is this the representation of the transitional stage between prokaryotes and eukaryotes? So right now the answer is, I don't know. But I'm sure many of us want to believe this. These are essentially the oldest three-dimensional microfossils ever discovered. And this is like 1.5 to 1.8 billion years old. This was actually present inside a relatively thin layer of aluminium silicates present inside various minerals. But even stranger, a lot of these appear to be multicellular, and some of them do appear to be quite complex. Here it was described as the fungi-like organism, but some of them also seem to contain some kind of a shell around the cells. But more importantly, a lot of these structures have never been seen before in any life. Definitely different from anything we observe today, or from anything in the last billion years. And in terms of size, some of these are pretty small, just over 10 micrometers in size, but some of these were large. Quite a few of these were at least several millimeters in size. The ones with filaments and with multiple structures seem to be the biggest. But exactly what any of this is anyone's guess. These are literally the first ever skeletons preserved in ancient samples that we can physically see and observe in 3 dimensions. Pretty much all of the other samples are usually from much younger animals, such as the ones from Cambrian explosion. And one of the main reasons we don't really have any samples from before is for one simple reason: skeleton. Anything that does not have skeleton is very difficult to preserve in fossils. Which is why all of the previous discoveries were just based on chemistry or based on interaction with the environment, not so much actual physical shapes. There were some, but they were extremely rare. But now we have physical representation of something that existed on a planet almost 2 billion years ago, and all of this preserved with relatively high detail. But I guess the question is, so what do we actually know here? So do we know anything about this life? Well, the only thing the researchers seem to be pretty certain about is where exactly this life might have existed, or basically what sort of life this was. And it was most likely terrestrial life, but not surviving on the surface, instead living inside some sort of a geyser-like structure, possibly hundreds of meters below the ground. And this geyser system potentially contained all of the necessary biological components required for the growth and proliferation of these organisms. So here they were basically surviving inside some kind of a cavity, possibly as deep as 2 or 3 kilometers. But because some of this water was extremely rich in silicon fluorite fluids, once the liquid started escaping to the surface, it almost instantly fossilized a lot of this life, while also creating all of the minerals the scientists recovered. With the main implication being that a lot of this very likely existed in extremely deep underground habitats, with many of these microorganisms very likely surviving and thriving right between the rocks. With one implication being that maybe this was not the most common organism that existed back then, and possibly just represented some kind of a niche, but because we actually find life in similar conditions on Earth today, comparing both in some of the future studies might provide some answers. At the moment, because this is just a brand new discovery, other than the actual pictures, there's just not much else. But the pictures themselves are definitely super cool. Just the fact that this survived for almost 2 billion years and is still visible today is already quite impressive. And because now we know where to look for more similar life, there might be more incredible discoveries from this unusual period in the next few months. Hello wonderful person, this is Anton, and today we're going to be discussing some of the new discoveries in regards to the spin of planet Earth and in regards to how much it changed in the last few billions of years. But more specifically, we're going to be discussing a discovery from a recent study that found something really intriguing about the mysterious period we sometimes refer to as boring billion. The period on planet Earth that lasted, exactly as it sounds, a billion years, during which, surprisingly, not a lot actually happened. For example, the continents remained more or less the same, there was not a lot of geological activity anywhere on the planet, and even the atmosphere and the temperature on the planet remained the same for a billion years. Surprisingly, there were also no major impacts either. So it's as if someone took planet Earth and possibly froze it in time. But life actually still evolved during that time, and as you might discover from the recent video in the description, there might have been an unusual organism we didn't know existed that could have been dominating the planet for that billion years. But in the more recent study, the scientists focused on something else. They actually found evidence that, surprisingly, even the actual rotation of the planet has not changed a lot, remaining at approximately 19 hours per day. Which by itself is actually really surprising because we expect the rotation of the planet to change quite dramatically over time. And so let's discuss this new discovery and all of these findings in more detail. But let's start with a brief history of planet Earth. Approximately 4.5 billion years ago, the planet received a collision from an object we refer to as Theia. This created modern Earth and our Moon, both of which you see right there. And as both objects evolved over time, quite a lot changed on both the Moon and planet Earth. Although more importantly, today we know that the Moon was obviously much closer to planet Earth when it was just formed. It was only a few thousand kilometers away from planet Earth, in the region we refer to as the Roche limit, or basically a region around the planet or a star, where technically the object becomes a ring. But by going a little bit farther away, the object starts to solidify, becoming its own structure, and in this case this is how the Moon became the Moon. And so as the rings around Earth changed into a single object, at some point this object started to exhibit a lot of tidal effects on planet Earth. Today we obviously refer to these as tides, but back then, as you can imagine, these were much stronger and potentially had extreme effects on the planet that we cannot even imagine. But one of these effects was in regards to the rotation of the planet. It's believed that when the planet was just formed, it was probably spinning really fast, possibly as fast as a single rotation per 4 hours. But the Moon gradually absorbed some of the Earth's rotation, slowing the planet down, while at the same time boosting the Moon into much higher orbit. And so within just 30,000 years, the rotation decreased by 2 hours, from 4 hours to 6 hours. And a lot of modern calculations create a kind of a curve here, basically suggesting that the rotation started to decrease quite dramatically at first, but over time decreased less and less. So for example, 2.5 billion years ago, when we believe photosynthesis appeared on the planet, it's quite likely that a single day was about 18 hours long. Intriguingly, there's actually a study that should be somewhere in the description that even made calculations about how fast the planet has to spin, or how slow it has to spin, for photosynthesis to actually be efficient enough and to work on a typical planet. If the planet spins really fast, and if a single day here is too short, it might actually not have enough daylight for photosynthetic life to produce anything. And so the planetary spin has to be slow enough for the daylight to be just long enough. In that paper, I believe the daylight had to be over 6 hours long. But based on previous mathematical models, the assumption was that the day was still decreasing in time, and after about 700 million years, or about 1.7 billion years ago, a single day was about 21 hours long. Whereas when the first multicellular life began on the planet, roughly around 1.2 billion years ago, the day was already 23 hours long. although in most cases most of these are actually based on mathematical modeling, not as much as actual samples or actual evidence. Once again, because this was the boring billion, during that billion years there are not a lot of samples and very few actual fossils to show us anything about anything. But it still made sense, at least mathematically, and especially because once we find samples and once we see evidence, especially in the last billion years or so, the changes in Earth rotation become quite obvious. And a lot of previous studies, especially the ones that produce really good evidence, came from the analysis of sedimentation rings around ancient corals. And many studies using these ancient corals show that the day was at least 1 hour shorter millions of years ago. You can actually find at least one video in the description that talks a little bit more about this, but the evidence here was pretty clear. And of course, made sense both geologically and physically in terms of what we know about the moon. The tidal effects from the moon are definitely pulling on the planet, slowing it down just enough. But a lot of this was based on much older studies and much older evidence, and using much older techniques. In the last years, the scientists have actually developed new techniques, and techniques that use something slightly different. One of these techniques is known as cyclostratigraphy, the study of much longer cycles inside various sediments, relying on the cycles we understand from astronomy. And the most famous cycles here would be what's known as Milankovitch cycles. The occasional changes in the way planet Earth orbits or spins on its own axis, which then very often influences certain climatic conditions on the planet. And specifically by using precession, which usually has cycles of 19 and 23,000 years, obliquity with a cycle of 41,000 but also 1.2 million years, and the cycles of eccentricity that seem to have periods of 100,000, 405,000, and 2.4 million years. And so even though previous studies mostly relied on these sediments produced as a result of tidal fluctuations, allowing us to discover hours per day in previous geological records, now it became possible to study even larger cycles by specifically focusing in the changes of orbits and how this then is reflected on the length of the day. And so during these cycles, the Milankovitch cycles, the way that the sediment deposits actually produces these patterns that can be then visible if you study enough of these samples from various locations. And precession and obliquity, which relate to the wobble and the tilt of the planet, seem to affect these samples the most, with all of these sediments creating a kind of a rhythmic layering that would be difficult to explain any other way. But all of this data is relatively recent. As a matter of fact, this project right here, the cyclostratigraphy project, has mostly collected the majority of the data in just the last 10 years. And so none of these studies would even be possible a decade ago. But they're definitely possible now, and this new paper has just discovered something we didn't know about, and that's somewhat difficult to explain. By looking at these resonances, they discovered that the length of the day was more or less stable at approximately 19 hours per spin for nearly 1 billion years during that boring billion, only decreasing further in the last 1 billion years afterwards. Or in other words, the average day on Earth was about 19 hours for that entire geological period, during which, once again, not a lot happened. And so instead of decreasing gradually and over time as previously assumed, the geological record suggests otherwise. It actually does suggest that the rotation changed dramatically prior to this, and then changed dramatically afterwards. But why, and I guess more importantly, why it didn't change for that billion years, is of course unknown. Or maybe unknown, because here the scientists propose one potential explanation. There's at least one mechanism that can physically affect the spin of the planet, and that does not involve the moon. Instead, it involves the other thing that has tidal effects on planet Earth, the sun. And so the reason they believe the rotation was more or less constant is because of very unusual tidal effects caused by the sun, specifically solar atmospheric tides. And so while the tides from the moon are responsible for slowing down the planet, or the rotation of the planet, and in this case it's mostly the liquid water tides responsible for this, here the sun itself would also provide a kind of a push from the charged solar particles that would very likely heat the atmosphere of the planet, and instead of pulling on the planet, slowing it down, they would instead excite or push on the planet, or the planetary atmosphere, resulting in the opposite effect, speeding the planet up. Or in other words, both the moon and the sun would create a kind of a counterbalance, with the overall rotation remaining the same for 1 billion years. But since the solar tides today are much weaker than before, it does not produce the same effects on the planet. But the obvious next question is, what kind of an atmosphere did the planet have back then, in order to allow the sun to produce these effects. Although obviously this is just one explanation for now, and there's no clear evidence that this is what happened. But because all of this is connected to that boring billion, it actually makes it even more intriguing and more mysterious. What exactly was happening on the planet approximately 1 to 2 billion years ago in order to create these unusual stable conditions for such a long period of time? It's one of the most mysterious and most intriguing periods in the history of the planet, and it seems to have occurred between two major periods when the planet was at its extreme. We had the famous Great Oxygenation event, when the atmosphere of the planet changed dramatically, very likely causing the first extinction event. More information in the video in the description. And at the end of the boring billion, we had the Cryogenian period, when the Earth became Snowball Earth, which is also the time when the first animals started to appear on the planet as well. Very primitive animals, but animals nevertheless. And so, by itself, these discoveries right now are really exciting. But this is just the first such study, and more studies with additional evidence and more data points. As you can see, there's only a handful of data points for this study right now, need to be conducted to basically tell us exactly what happened back then and how Earth was different from today. But I guess more importantly, the rotation of our planet seems to be related directly to the exact composition of the atmosphere. Since this happened a little bit after the first oxygenation event, when a lot of photosynthetic bacteria became extremely prominent on the planet, one assumption here is that all of this life that existed on the planet potentially dramatically transformed the atmosphere through very active photosynthesis that changed the composition so much that it allowed for these unusual solar effects, resulting in solar tides. Effects so powerful that they lasted for 1 billion years, allowing the planet to ignore the effects from the moon, which was much closer and much more gravitationally potent. And so whatever answers we find here, they're probably going to help us discover more about the origin of life, and more importantly, the origin of complex life. Because it does actually look like a lot of this seems to be somewhat related. The sudden appearance of photosynthetic life seems to be correlated with the boring billion, and the sudden appearance of multicellular life or more complex life is correlated with ice ball Earth and the emergence of very complex life on the planet. But exactly what happened here and exactly what all of this means is not something we're going to know for probably a few years at least, possibly longer. Hello wonderful person, this is Anton, and today we're going to be discussing a new study that just came out a few days ago that proposes another unusual cycle on planet Earth that we've never known existed, but seems to affect the amount of biodiversity on the planet. And it does so every 36 million years. And so in this video, let's actually discuss exactly what the scientists discovered so far, what this potentially means for our understanding of planet Earth, but also talk about what exactly drives this cycle and what effects it has on the planet. But first, let's start with the basic concepts. The concepts of biodiversity and the idea of extinction. Something we always hear about in the news, but something that's not necessarily well explained. For example, here's an incredible map of terrestrial biodiversity on the planet. What this essentially shows you is the amount of various vertebrate species, or the amount of various complex animals, present in various terrestrial locations on the planet. As you can see, some of the highest biodiversity, which is in red and in orange, is essentially in parts of Africa, some parts of Southeast Asia, and of course, Brazil. Most of it is in Brazil. But in this case, it's not really telling us about the amount of animals, it just tells us about the biodiversity, the types of animals in that particular location. But generally, locations that are more hospitable to life will always have more biodiversity. So for example, in a desert, you're not going to find as much biodiversity as you would in a forest or in some kind of a jungle. But this doesn't actually tell us anything about the total biomass or the total number of animals, or even how successful animals are in these locations. As a matter of fact, some of the least hospitable locations on the planet often have way more biomass. For example, this Japanese island known as Nishinoshima is practically barren on the surface, but it recently had a volcanic eruption that created a huge bloom of various algae visible from outer space, overall increasing the biomass by a relatively large amount. Something very similar happened after the eruption of Tonga, with the total biomass, as you can see right here, being in hundreds of kilometers in terms of size. And so biomass by itself is not always correlated with biodiversity. And that of course implies that even during, for example, extinction events, which by definition is a sudden decrease in biodiversity on the planet, doesn't actually mean that it's going to change the biomass in terms of size and mass. All of these new conditions on the planet might instead quite often result in the opposite. They actually result in a huge bloom of a lot of bacteria or algae, or possibly some other animals that were previously just a tiny niche, invisible otherwise. But when it comes to extinction events, especially the so-called Big Five extinction events, we normally define them as the sudden decrease in biodiversity on the planet, with the most famous one being the one that killed the dinosaurs 66 million years ago, but the more recent one only happening approximately 34 million years ago, and referred to as Eocene-Oligocene extinction event. The event that also involved a dramatic decrease in a lot of different biodiversity, especially in the marine life, but the event that doesn't have a very good explanation even today. And although two potential craters have been discovered that could have actually caused this, one in Russia and one in the US, they don't really provide enough evidence for any of this, especially because, generally, just a single collision will often not result in a major extinction. And so even though a lot of people assume that an extinction might be caused by some kind of an asteroid event or a large collision somewhere on the planet, in reality the evidence suggests otherwise. Especially because these two craters were most likely formed millions of years apart, and at least a million years before the extinction event as well. But in the last decade or so, the scientists developed even better time maps showing us biodiversity across hundreds of millions of years. Here's one of the better ones that basically shows us that biodiversity does actually change quite a lot pretty much every few million years. But more importantly, showing us that it almost looks like there's some kind of a cycle here. And because a lot of these events never actually had any explanation or an explanation that would be definitive, it basically presents paleontology with another mystery. What exactly is causing sudden changes in the number of species on the planet, especially if it doesn't involve something very obvious? Here we're talking about some kind of a major volcanic eruption or some kind of an asteroid impact. And that's sort of what this new study is about. They basically worked out a pattern that seems to suggest there is actually a cycle, and it's approximately 36 million years, with the cycle in this case driven entirely by the geology of the planet, specifically by the idea of plate tectonics and the increase or decrease in the ocean levels. And all of this was based on two things. First, a much closer look at the fossil record, focusing on biodiversity in the last 250 million years, but then also combining this with a simulation of geological motion or plate tectonics using the script known as G-plates that you can find in the description. And in the end, the simulation established that roughly every 36 million years, the plate motion on the planet results in a dramatic change in the sea levels, resulting from either increase or decrease of the amount of seafloor spreading that happens on the planet, which then surprisingly results in a kind of a cycle that changes the total depth of the oceans and the amount of water that's transferred into the Earth's crust, which can then produce even more volcanism. And so the motion of the plates and the spreading of the seafloor changes the ocean levels just enough to then cause dramatic changes on the surface of the planet, either increasing flooding or increasing the amount of deserts and the amount of dry land, with most biodiversity occurring when there is actually a lot of different shallow seas across the entire planet. But when the ocean depth changes and the shallow seas either dry out or become deep ocean, that's when we suddenly observe a decrease in biodiversity, which can also be seen as an extinction event if it happens in a lot of regions on the planet. For example, the spread of the seafloor across various oceanic plates creates larger and larger oceans and thus decreases the overall water levels over time. Likewise, subduction zones reduce the total ocean floor as some of these plates are then swallowed underneath the continental plates, eventually recycling all of this in the process. And so both types of plate tectonics can actually vary the overall ocean levels quite dramatically, with the discovery here suggesting that it's also cyclical. And more importantly, seems to correlate directly with the biodiversity cycles of 36 million years. And though it's possible that some of the extinction events could be associated with this as well, at the moment none of this is definitive, and it just shows us that the actual cycles on the planet are just way more complex than we ever thought. More importantly, providing evidence that the tectonic plates have their own cycle as well, and they seem to influence the ocean just enough to then influence life. Now this is of course just one of many cycles. As a matter of fact, the team behind the study might have found a second cycle that's about 62 million years, but none of this is definitive just yet. As always, extraordinary claims require extraordinary evidence. Although I guess one important caveat here is the fact that this is mostly, at least for now, based on the fossils from marine animals, not from terrestrial animals. As a matter of fact, for all we know, maybe it has the opposite effect on the biodiversity on the surface. But because we don't have enough fossils to study any of this, it will be difficult to confirm this, at least for now. But assuming that the scientists behind the study are correct and discovered a new cycle, I guess the more intriguing question here would be, does this actually mean that EOG event, or the Eocene-Oligocene extinction, might have been caused by this as well? And if this was a result of this cycle, with the event happening 34 million years ago, and affecting the biodiversity of a lot of marine animals on the planet, well, does that mean that we're in for another one in a couple of million years? Now, obviously, this is not something we can prove just yet, but assuming that the scientists are correct here, in about 2 million years, the planet might actually start changing again, reducing the overall levels of water, shifting the overall biodiversity once again. But I guess exactly how, or what exactly would happen to the planet, is not something we're going to know just yet. Nevertheless, a pretty intriguing discovery and a pretty intriguing study, and something we'll discuss more in some of the future videos. Personally, I always had a strange fascination with large craters created by massive impacts somewhere on planet Earth. Probably because I always loved dinosaurs, and discovering that an asteroid potentially caused their demise made me super curious about other potential collisions that might have been even more powerful. And based on the size of our planet, it's technically supposed to be covered in craters, and at some point it probably was. But because of a lot of geological activity on the surface, most of them have been erased a long time ago. But you can kind of imagine how many impacts planet Earth must have had by just looking at the surface of the moon. Without geological activity, everything here was frozen in time, and the number of impacts here was probably much lower. Nevertheless, in the last few decades, scientists have actually discovered several impacts that are definitely much larger than you would expect, with 3 now becoming really famous and pretty well known. Now, the most famous one, the Chicxulub crater, is of course the one that happened 66 million years ago and killed the dinosaurs. This unusual crater, roughly around 170 kilometers in diameter, was only discovered a couple of decades ago and is part of what's known as Alvarez Hypothesis, originally proposed by Luis Alvarez and his son Walter back in 1980. But it wasn't until mid to late 90s, and more specifically until the last couple of decades, that this explanation has been generally accepted to be correct, with this now being certainly a large crater. Although the person behind this, Luis Alvarez, deserves a separate video because this guy is just absolutely insanely brilliant. A Nobel-winning physicist who's been responsible for a large number of incredible discoveries, one of them being this. But there are 2 other craters on the planet that are considered to be larger and definitely more destructive, although they might have actually been created a long time ago. The most famous one in North America is the one that many Canadians have driven through many times. It's actually right here in the Sudbury region, and it's essentially known as the Sudbury Basin. And intriguingly, if you ever drive through this region, it feels really eerie, because you actually do feel like you're inside some kind of a crater. There are certain regions there that drop by several hundred meters all at once, with these huge regions of forests just growing on the bottom of the crater. At least that was my impression when I drove through here back in like 2005 or something. And this crater is a little bit larger, but was also created approximately 1.8 billion years ago, during the famous Boring Billion. This is actually one of the few events we know occurred back then, with pretty much nothing major happening otherwise. If you've never heard of Boring Billion, you can check out one of the videos in the description explaining exactly what it is. And so for a lot of Americans, this is maybe one of the coolest locations to visit if you love craters. But the biggest structure has always been in South Africa, the famous Vredefort impact structure. It's actually large enough that you can technically see it from outer space if you know what you're looking for. But because this is actually an ancient structure, it is so much challenging to actually find it without knowing what to look for. So here's this unusual structure you see right here, with the remnants of the impact still present to this day. But this structure is technically much bigger. It's approximately 300 kilometers across, and most likely formed about 2 billion years ago. So basically when Earth was mostly dominated by bacterial life. And this has always been the largest crater known to us. But even here, the impactor was probably not very big, maybe 10 to 15 kilometers in size. Definitely much smaller than some of the impactors we find on the surface of the Moon and of course Mars. For example, in case of Mars, something really major must have smacked into it in order to create unusual formations across the entire northern hemisphere. And so the question has always been, what about Earth? Why are we not seeing these impacts more often? And so obviously similar impacts very likely happen on Earth as well. But because of the powerful erosion forces mixed with plate tectonics and a lot of other geological activity, including volcanism, after billions of years, all of them pretty much disappeared. And since a lot of them were probably in the oceans, they are unlikely to have left a lot of clues behind. Nevertheless, some scientists out there never give up. They always believed we're going to find more just by looking for various anomalies on the planet and by looking at various geological records by dating certain rocks in those locations. And it looks like, maybe, just maybe, scientists have just found another one right here, in the Down Under, somewhere in southeast part of Australia. And this is actually really exciting, because if confirmed, this would make it the biggest crater we've ever discovered, and also potentially the second crater that might have been responsible for another extinction event. So, hello wonderful person, this is Anton. Today we're going to be discussing this really unique discovery that basically suggests Australia has been hiding a huge crater for many years, and it might have been a colossal event even bigger than the one that killed the dinosaurs. Discovered near a location known as the Niliquin municipality, and in essence, even visible to some extent on this map right here. I mean, this might be a part of it. So yeah, let's discuss the details. Interestingly, unlike other regions on the planet, Australia does not really have as much erosion and tends to preserve very ancient structures. The entire continent currently contains 38 confirmed craters and 43 potential impact structures visible on this map. All of the green and red dots represent confirmed structures. Red ones are actually really big, potentially more than 100 kilometers wide, with the yellow dots representing potential structures. And notice how there is an unusual region that seems to contain an ejecta from ancient impact. Basically, this is the leftovers as they fell onto the planet after some kind of a major impact. Now, in the past, some of this ejecta has been associated with what's known as late heavy bombardment that happened approximately 3.2 billion years ago. But sometimes the ejecta can actually be used to find a potential more recent crater by essentially looking at where it possibly came from and trying to trace back the origin. And the thing is, the two scientists behind this study have been actively trying to figure out what's happening here since the late 90s. But it was after 2015 and around 2020 that they finally started to find clues by using various magnetic maps produced by various satellites. And here, by looking at magnetic intensity, you suddenly start seeing an unusual ring structure and a lot of multi-ring patterns usually associated with craters. Very similar structures can be found in the Rutherford and Sudbury craters as well. And over several years, by using different magnetic maps, it became possible to start seeing these features that would be actually otherwise very difficult to explain. For example, there are obvious signs of symmetrical rippling pattern, as if something smacked from the top, disturbing hundreds of kilometers of ground underneath. In some sense, it's very similar to what you expect from, for example, a rock or even a droplet falling into the water, producing similar wave-like structures on the surface. So this is kind of what we're seeing here as well, except that it's basically the ground. With all this implying that it was produced during an impact with extremely high temperatures and very intense magnetic fields, with several other structures visible as well. For example, the top of the dome is approximately 10 kilometers below the mantle, and there seem to be also signs of radial faults moving away from the center. These features are very similar to other very well-known craters. As a matter of fact, it's almost identical to what we find around Rutherford. And so, is this basically the new record holder? Well, it most likely is, but it will be very difficult to definitively prove this unless we get the samples, specifically samples containing shocked quartz or a lot of other similar formations expected from a massive impact. And so something like this has been obviously done for other well-known craters, but in this case, it would be a bit of a challenge. We would actually have to somehow drill several kilometers deep into the ground in order to collect necessary minerals that would be required to not just prove this, but to also date this, essentially figuring out exactly when this happened. Now, based on the assumptions from previous studies about this region, at the moment it's assumed to have happened anywhere between 445 to maybe 470 million years ago, or maybe even 520 million years ago. So the actual date is not clear right now. With the impact happening on the eastern part of Gondwana continent, right before it split into other continents, including Antarctica. You can actually try to visualize this using this beautiful map created by Ian Webster, and here, by going back in time, we can sort of start seeing what Earth looked like approximately 470 million years ago, or even 500 million years ago, as well as 540 million years ago, when Gondwana continent was in existence. And so it's quite possible that somewhere in this region right here, when early life was still developing and becoming more complex, a major impactor suddenly interrupted everything. And if this indeed happened approximately 450 million years ago, it might have been responsible for what's known as Ordovician-Silurian extinction event. One of the biggest extinction events that suddenly erased 85% of all species on the planet, and might have been at least twice as damaging as the event that killed the dinosaurs. The extinction event that suddenly erased a lot of really strange mollusks with these cool looking heads, making them suddenly disappear from the planet. Their weird heads, by the way, might have been left in the mud in the oceans, potentially sticking out all across the surface, mostly because they seemed to be everywhere back then. And so exactly what happened to them has always been kind of unknown, but the impact hypothesis could provide some answers. But it could have also happened at a different time, and so we're actually not going to know exactly when, until someone is able to collect the samples from underneath all of this. But drilling this would be very difficult. We would have to reach depths of over 10 kilometers. And so at the moment this is an interesting hypothesis, but it's not going to be proven anytime soon. But when it comes to this being a crater, it almost certainly is. It's very difficult to explain all of these features without some kind of a large impactor, and as far as I know, there is no alternative explanation to any of this just yet. Which of course means that we now have a new record holder on planet Earth, the largest crater ever found, potentially double the size of the previous record holder from South Africa. This here is about 520 kilometers across, and potentially responsible for stealing all of these cool heads from these unusual creatures, leaving all of them across the oceans. Hello wonderful person, this is Anton, and today we're going to be discussing some new unusual discoveries from within planet Earth. And when I say within, I really mean within, because turns out something else really exciting was always hiding on the inside, extremely close to the core of the planet, basically surrounding the entire core. And in this case, the scientists behind this recent study believe it represents some kind of an extremely ancient ocean floor. The ocean floor that used to exist on planet Earth billions and billions of years ago and contained some really intriguing features, including huge mountains several times as big as Mount Everest, with all of these features potentially visible in these new observations. And so in this video, we're going to talk a little bit more about how exactly this was discovered, what all of these concepts are based on and what they're called, and what they mean for our understanding of planet Earth. And if you've been watching this channel long enough, you probably know that this is not the first unusual discovery coming from within the planet. So many new unusual features have been discovered inside planet Earth in just the last few years. And some other structures that were known to exist for a long time, because of new detailed observations, have now been definitively proven to exist, allowing the scientists to actually now explain a lot of properties on the planet that we observe over time. And one of these unusual properties, or anomalies that's sort of been bugging scientists for several years now, is a peculiar structure today referred to as the South Atlantic Magnetic Anomaly. It's basically an area around South America that seems to contain much lower magnetic field compared to the rest of the planet, and it seems to be a result of something happening very close to the core of the planet. Specifically, one of the structures that seems to be affecting the magnetic field and basically results in a kind of a magnetic hole. And though it's not really something that affects us on the surface of the planet, it's definitely something that affects satellites passing right above this anomaly, which is why most of the studies to date have been usually done by NASA scientists. Some of the links in the description directly from NASA explain this a little bit more. A lot of these effects are potentially caused by what's known as large low shear velocity provinces, illustrated right here, which some scientists believe may be remnants of ancient planet. Specifically, the ancient planet referred to as Theia, believed to have been responsible for the production of the moon. And so the remnants of this planet basically ended up inside Earth and are now producing all sorts of effects on the surface. But that's just one unusual discovery from the last few years. The scientists have also identified what seems to be an additional core inside the inner core, suggesting that there are at least 5 different structures inside the planet. This is actually one of the more recent discoveries, and even today the scientists are not entirely certain what this actually means for the planet. But this innermost inner core definitely contains its own properties and also seems to be made out of something entirely different. You can find more details in some of the videos in the description. But in the last few years, the scientists have been also finding something else. Some other unusual structures right above the core, but below the mantle of the planet. Most detected through various very detailed observations using seismic waves, and essentially discovered when an earthquake passing through some of these areas end up producing additional waves or end up reducing the speed of the waves by as much as 40%. And because of this, these unusual areas are now referred to as ultra-low velocity zones, ULVZ. And the thing is, these were discovered quite a few times by different researchers, but it wasn't really clear what these mean. With separate studies identifying at least two very large areas only visible in certain regions. For example, we have the Hawaiian ULVZ, an ultra-low velocity zone located right above Hawaii, that seems to be the largest such object mapped to date, at least 1,000 kilometers across and approximately 20 kilometers in height. With the second largest being the Samoan ULVZ, approximately 800 by 250 kilometers in size and 10 to 15 kilometers in height, with the seismic waves passing through this region reducing in velocity by approximately 45%, implying that this is something extremely dense inside planet Earth, something really compressed and something enriched in a lot of different dense elements. But it's really because of these extremely recent, very detailed observations that the scientists were able to potentially work out what this is. By using 15 different monitoring stations located in Antarctica and mapping this over 3 years by listening to seismic waves, they were able to produce an extremely accurate observation of the three-dimensional shape of these unusual features, realizing that they seem to resemble mountains, and also producing a much more accurate two-dimensional map of where all of these features are located. Here you can actually see both LLVPs, large low-velocity provinces, which are believed to be the result of the Theia collision, and ULVZs, which seem to be very different. And the conclusion so far is that these are two separate anomalies, based on two completely different physical phenomena. Since the velocity inside ULVZs is much lower than anything else, it really suggests that this is an extremely thick and very dense material. And because the thickness of this material is much lower than anything else, from only a few kilometers to maximum a few tens of kilometers, with the average shape kind of resembling a mountain, this was of course the first hint. Maybe these were ancient mountains. And by then comparing this to locations around the planet, it sort of became a little bit more obvious how all of this was produced. All of this was highly correlated with various subduction zones on the planet, where we have a lot of interaction between various oceanic plates and continental plates. And as these plates push the rock down into the Earth's interior, they basically create these very large island-like structures that, because of their high density, end up sinking deeper and deeper, following the circulation of mantle all the way down to the surface of the outer core, and eventually get deposited right above the core, intriguingly creating a completely different surface deep inside the planet, which sort of implies that the ancient oceanic crust and all of these ancient mountains are sort of wrapped around the entire core, almost like the second surface. Which I'm sure might excite a lot of fans of stories like Jules Verne's Journey to the Center of the Earth, or proponents of the Hollow Earth. Except that it's not really hollow, and nothing would be able to survive in these conditions. We're talking about thousands of degrees Celsius and extremely pressurized environment. So don't expect another world inside planet Earth. But the existence of an actual ancient seafloor, with what seems to be ancient mountains, some of them up to 40 kilometers in height, for anyone studying geology and especially geology of ancient planet Earth, is already super exciting, and there are so many reasons for this. First of all, obviously, it allows the scientists to finally figure out what ancient Earth might have looked like, especially when it comes to the interaction of ancient oceans with the ancient crust. It also, to some extent, allows us to study ancient geology of the planet by potentially investigating what sort of mountains existed here, but more importantly, it might even provide evidence for the existence of ancient life, or what sort of life existed here. There's an older video on the channel that you can find in the description that talks about this hypothesis of basically how life, specifically primitive bacterial life, is directly correlated with the existence of large mountain ranges on planet Earth. In other words, some of the larger mountains on the planet might have potentially been a result of various life-based activities on the surface of the planet. And so the existence of these structures and the ability to study these structures using modern technology might actually help the scientists solve quite a lot of intriguing things about ancient planet Earth. Although I guess just the fact that the core of the planet seems to be covered by an ancient seafloor is already pretty cool as well. Although here we still have to remember that this is still a hypothesis. As the authors mention in the paper, there could still be other explanations or other options. But no matter what this is, it's going to help a lot of geologists figure out how the heat exchange inside the planet seems to work, and how all of this then results in various observations we see on the surface, including strange magnetic anomalies or even various gravitational anomalies that up until recently could not really be explained. And so basically, as a result of these recent, very detailed observations, in just the last few years, the scientists were able to learn so much about planet Earth. So let's discuss a mysterious structure inside planet Earth. Something geologists discovered decades ago, but something that did not make sense at first. We're talking about the structures you see right here. These very large formations right above the core of planet Earth and sort of floating in the mantle. Here's actually a beautiful simulation kind of showing us what all of this might look like. And if you've been on the channel long enough, you probably already know exactly what this is. These are known as LLSVP, large low shear velocity provinces, representing a much denser region inside the planet, with the African and the Pacific LLSVP being the largest and the main provinces, extending for thousands of kilometers in every direction and at least 1,000 kilometers upwards. Intriguingly, many of these locations also seem to be very close to various hotspots, usually responsible for major volcanism. In other words, geologically speaking, these are some of the most important unusual features inside the planet. But the question is, of course, what are they? How did they get here? And is this something very common or something very rare? And I think something like 2 years ago, we've discussed this somewhat intriguing proposition that actually wasn't proven back then, that maybe, just maybe, this is actually a remnant of a planet. Specifically, a remnant from the collision 4.5 billion years ago that in essence formed modern Earth, while also forming the object around Earth. This is of course the origin story for our moon. And so yeah, hello wonderful person, this is Anton. Let's discuss this new study once again, mostly because it has now been officially published in the Nature magazine. It now presents a lot more proof and very clearly states that there's a very high chance that LLSVPs are really the remnants of ancient Theia, the planet that collided with proto-Earth in order to then create the moon and the Earth we know today. But initially it was always believed that most of Theia very likely ended up inside the moon, with maybe some of it mixing with the mantle of planet Earth and essentially becoming a kind of a well-mixed substance that would explain why the Earth and the moon seem to have relatively similar composition and very similar isotopes, with a lot of simulations like this one also more or less proving the same. But the international team from China, US and UK have recently confirmed their initial assumption, more or less opposing this idea of homogeneous Earth, or basically Theia and Earth being mixed into one single structure, and also explaining a lot of other important features about our planet. First of all, we know that when this happened 4.5 billion years ago, this actually sort of started the geological evolution of planet Earth. This enormous impact kick-started everything, while also changing the planet just enough to make it unique and to make it different from everything else. And a lot of this is possibly due to these unusual structures inside the planet. So where exactly did they come from? Well, initial explanations involved sinking continents that would eventually end up inside planet Earth, melting and forming these unusual thicker regions. And this might explain some of the features we see inside the planet, but not the most massive ones, and definitely not the densest ones. It would actually not make sense why some of them would be so dense that they actually sink to the bottom, because most of the continents for the most part have a relatively similar density. Yet both the African and the Pacific Ocean LLSVPs seem to be about 2 to maybe even 4% denser than the mantle of the planet. They seem to be very rich in iron, which is why they sink and stay on the bottom right above the iron core. Some studies have also suggested that maybe this is just a slightly higher temperature spot, or even some kind of a very thick magma ocean that formed over billions of years. And though these are also intriguing propositions, there's no explanation for the mechanism of how exactly all of this would form, or why it would exist. For example, why did it form exactly in those two spots, and not really in other spots around the planet? And so a much more intriguing proposition was in regards to this being leftovers from the collision that formed the moon. And though before it was always assumed that a lot of Theia was actually present inside the moon, making the moon maybe a little bit more iron-rich and a little bit denser. A few recent observations and a few recent calculations kind of disagree with this, especially because lunar rocks don't seem to be too different from the rocks on planet Earth. Now this is actually something that's going to be proven later on once scientists can collect more rocks from the moon. So basically if a lot of them are denser, maybe the moon is the leftover from Theia. But at least for now, it does not seem to be the case. The density of both objects seems to be relatively similar. And so here, to come to a conclusion, once again the scientists ran very complex computer simulations. And really just to do one thing: observe the effects of this giant impact, focusing on how the material spreads across the planet and where it settles at the end. And well, in their simulations, they kind of managed to show exactly what they always believed. The spread of the material across the planet seems to indicate that following this very powerful impact, a large chunk of Theia, or even in this case 2 chunks, are in essence going to create certain structures inside the planet, very likely somewhere on top, basically in the upper mantle, with the lower mantle remaining more or less solid and more or less untouched. But because a lot of these chunks were slightly more dense, approximately 2 to 3%, with time they would stratify, with a lot of these chunks sinking to the bottom, at first forming smaller chunks of about maybe 10 to 20 kilometers across, but eventually accumulating into larger and larger objects. And after a few million years, very likely combining into these large objects we now see inside the planet, basically representing about 2 to possibly 3% of the Earth's mass, and very likely representing a relatively large chunk from Theia itself. But more importantly, solving the mystery of LLSVPs, explaining these unusual geological formations and why they seem to be the center of a lot of volcanic activity, and I guess even more importantly, explaining why Earth is kind of unique. For example, as I mentioned in one of the previous videos, turns out that our planet, compared to, for example, Mars, has a dramatically higher number of various minerals. Earth has several thousand minerals on the surface, potentially the result of a lot of this mixing and interaction early on, which, for example, planet Mars does not have. In comparison, something like 150 minerals were discovered on Mars. That's dramatically lower. It also potentially presents us with a very important factor that made Earth the way it is. Essentially habitable, very active, and containing a variety of geological effects and geological structures inside the planet. At this point, it's a bit of a speculation, but it's also kind of implied that these events and these structures might have been responsible for a lot of early volcanism, a lot of early evolution of the planet, and even possibly plate tectonics. Or at least a major mixing of the entire mantle, and thus a much more enriched planetary surface after billions of years. And so there is actually a very high chance that this is something fundamental that needs to happen to a planet in order to create these geological differences and to even possibly form conditions for permanent life. At the least, it seems to explain why the planet seems to be so different, so unique, and very different from any other terrestrial planet in the solar system, or anything we've seen so far with various telescopes. And so for all we know, the presence of these unusual dense formations, resulting from the collision with another planet, may be the real reason why planet Earth is so strange, so different, and of course, is able to create creatures like us. And though at least for now it's still a bit of a hypothesis, there's maybe a way to test this in the future once the scientists are able to collect more rocks, the rocks from the moon, and then compare them to the ones from Earth. If the lunar density is higher than planet Earth, there's maybe a chance that this idea is incorrect. But assuming that all of the rocks studied in the future are going to have similar density to planet Earth, like they usually do right now, it would basically confirm that most of the lunar material must have been mixed with planet Earth, and a large part of Theia potentially ended up inside the planet. And more importantly, if all of this is confirmed and if this is indeed what's happening here, it also implies that this is maybe a kind of a natural consequence when various planets collide around other star systems as well. These impacts are probably very common. As a matter of fact, we've just witnessed one not so long ago. You can learn more about this in the video in the description. And so it's quite possible that many of these planets actually end up having very similar structures inside, and this unusual planetary accretion possibly happens in many objects out there. And if so, this actually gives us a very high chance for maybe one day discovering yet another Earth. Or at least another planet with very active and very advanced geology on the surface, lots of minerals, lots of chemical processes on the surface, and thus maybe some kind of a unique life. Relatively recently, there was a really intriguing study that focused on the concept of runaway greenhouse effect. The idea behind the phenomenon where a planet reaches a certain temperature where all of the greenhouse gases start to accumulate practically exponentially, indefinitely warming up the planet until it becomes completely uninhabitable and extremely hot. And this is of course a really important concept for us to study because of our neighbor, Venus. Venus is a good example of what happens to a planet when this effect occurs and the planet loses all of its water, becomes entirely covered in various greenhouse gases, and remains extremely hot with extremely high pressures of atmosphere for basically billions of years, potentially indefinitely. And so extremely recently, French scientists conducted one of the most accurate simulations in order to discover, Earth. Can this happen to our planet? And if so, how? And they did make some really intriguing discoveries. And so today we're going to discuss some of the results and what this means for our planet, but also, I guess, talk about some misconceptions as well. And very quickly, let's start with that. I think the word greenhouse gas, because of political implications, today is basically misused for a lot of different misconceptions. And that's because usually it's associated mostly with carbon dioxide released by various industries. But in reality, pretty much most gases can be greenhouse gases to some extent. Methane is obviously a very powerful one, we've discussed that in one of the previous videos in the description, so are nitrogen oxides, and so is water vapor. And water vapor is a really important one because it actually increases the overall strength of other greenhouse gases and does have a much wider absorption spectrum compared to everything else. Here's actually another way of trying to visualize this, and it basically shows us the amount of absorption based on the wavelength of light. And as you can see, water in this case has a very wide absorption spectrum. This will become important later on. But today we're not really talking about the climate change, we're not really talking about the human contribution to any of this, we're not discussing anything political. We're talking about a much more, dangerous scenario that we know is going to happen eventually, but the scenario that the scientists want to understand more, because the question here is, hypothetically, can Earth actually reach the same conditions as Venus at some point? And if so, what exactly would need to happen to the planet in order to achieve this runaway greenhouse effect? And so, hello wonderful person, this is Anton. Let's discuss this somewhat hypothetical and somewhat intriguing scenario that answers this question to some extent, with the study actually discovering that apparently it would not take much for Earth to turn into Venus. And it might have almost happened a long time ago. But I guess first, let's start with the obvious. It's extremely unlikely that even if we release all of the carbon dioxide stored in fossil fuels, we'll ever be able to reach these conditions, and so no matter how hard humans try, we're not going to be able to turn Earth into Venus, at least based on calculations from fossil fuels and from carbon dioxide. And even with the extremely high levels of carbon dioxide in the atmosphere, which has happened in the past approximately 400 million years ago, we're just not really going to get there yet. Here's actually a graph showing us that carbon dioxide levels were very likely at least 10 times higher than they are today for a pretty long time. And during that time the temperature was very likely close to about 40 degrees Celsius on average. Today it's only about 13 to 14 degrees. And naturally we know that Earth survived this and did not become Venus. But all of these older models mostly focused on carbon dioxide for obvious reasons. Basically just to establish if fossil fuels could one day lead us to this. And so some of these older models usually ignored other gases, while also generally using a much simpler one-dimensional models. Science time. In scientific terms, the runaway greenhouse effect is also sometimes referred to as Kobayashi-Ingersoll limit, essentially representing a limit when the planet can no longer lose enough heat and instead keeps accumulating heat on the inside its atmosphere, becoming hotter and hotter over time. And we know that for Earth, theoretically, this limit is going to be reached when the sun starts to emit approximately 10% more luminosity, or basically becomes about 10% brighter. This will most likely happen approximately 1 billion years from today, with the average temperature on the planet finally reaching approximately 47 degrees Celsius, 117 Fahrenheit. And it's actually once we reach these temperatures where things start to transform extremely rapidly. And at this point, it's not carbon dioxide or even methane that becomes a problem, it's actually water. Which is exactly what this new study focused on. Here they were able to simulate the runaway greenhouse effect by focusing on what happens when water starts to evaporate from the surface of the oceans. and specifically focusing on the main effects that are going to be driving these extreme changes in the environment. And so it turns out that as soon as we reach this temperature of about 47 degrees Celsius on average, which is obviously going to be higher in certain locations, lower in other ones, a slight increase in evaporation from the surface of the oceans will suddenly dramatically increase the greenhouse effects from the water, thus increasing evaporation even more, leading to more and more water accumulating in the atmosphere as various types of clouds. And this is actually the first time ever that the scientists focused on this transition stage itself, trying to see what exactly happens to the planet as it goes from being habitable and having a liquid ocean to basically becoming Venus, with one of the main discoveries suggesting a formation of very unusual clouds that will very likely form around the entire planet and potentially permeate the entire stratosphere, creating a kind of a layering effect, practically allowing no heat to escape. And these super dense clouds that will suddenly even appear much higher in the atmosphere will basically begin an irreversible greenhouse runaway effect. By dramatically altering the atmosphere and continuously increasing evaporation from the oceans, this basically begins a process that is impossible to stop. It causes the planet to suddenly acquire a much higher atmospheric pressure, a much higher content of water vapor, and, most importantly, an extremely high greenhouse effect. All of this driven by a large amount of surface ocean that existed here for billions of years. And after evaporation of only 10 meters of surface water, the atmospheric pressure would actually double, very likely leading to temperatures of over 500 degrees Celsius within a very short period of time, potentially just a few hundred years. And at this point, this is completely unstoppable. The ocean will continuously evaporate, add even more pressure, create even more extreme conditions, and basically create the planet completely void of water with an extremely thick, gooey conditions on the surface formed by highly pressurized water vapor, with the final temperatures and final pressures very likely being approximately 1500 degrees Celsius and approximately 273 atmospheric pressures. All of this occurring in possibly just under 1000 years. And so once the planet reaches these extreme conditions, that's basically it. It's now technically primordial Venus. But because all of this forms a very thick layer of water vapor, now all of this starts to interact with the sun, beginning the new process of photodissociation. The H2O molecules will fall apart and create hydrogen and oxygen. Hydrogen escapes into the rest of the solar system, oxygen very likely forms something on its surface, or potentially creates more CO2. And this begins the next stage, the so-called second stage known as dry transition phase. Here the water will slowly disappear, but over time become replaced with CO2 and possibly a few other gases. At which point, Earth becomes a slightly more extreme version of Venus because it does have slightly more carbon to create carbon dioxide. And this study once again confirms that this is exactly what probably happened to Venus a few billion years ago. Because it's much closer to the Sun, it started to lose its ocean, it reached the Kobayashi-Ingersoll limit much quicker, and its water started to evaporate much quicker as well. And there's a lot of evidence for previous existence of water here because of an extremely high deuterium to hydrogen ratio in Venusian atmosphere. It's about 150 times the amount we see from planet Earth, and it suggests that heavier isotopes, deuterium, that very likely came from the oceans that used to exist here, are still lingering in the Venusian atmosphere. But one thing that makes Venus different from planet Earth is that unlike Venus, Earth does have plate tectonics, at least for now. And so that's why Venus has so much carbon dioxide on its surface, because it mostly never got to go inside the planet, with volcanoes constantly releasing more carbon dioxide into Venusian atmosphere. But a lot of carbon is trapped inside planet Earth, and so for at least some time, the carbon dioxide levels on planet Earth are going to be pretty low. As a matter of fact, once all of the water vapor disappears, there might even be a period when the planet might become possibly slightly cooler and maybe even somewhat more hospitable again. But because plate tectonics at this point might actually shut down as well, constant volcanism and constant geological activity will eventually release more and more carbon dioxide as well, and so at some point it will go back to being super hot again. But this would take hundreds of millions of years and possibly even billions of years, and so there might be a very intriguing period on the planet after it loses its water vapor when it's actually kind of empty on the surface, but possibly not too hot. But during this water vapor stage, it is going to be super extreme. As a matter of fact, it's going to have extreme everything. Extremely powerful wind speeds, very thick atmosphere that's not going to allow any light through, and super pressurized, super hot, and quite exotic conditions right on the surface. And so yeah, Modern climatology studies definitely imply that our planet is not going to stay the way it is forever. It might have maximum 1 billion years from today, and after this, things will actually escalate pretty quickly. But this study also provides us with some really important implications in regards to exoplanets, as well as reminds us of how precious and how unique our planet is after all. Too little greenhouse, and it becomes an ice ball. Too much greenhouse, and it becomes a heated sauna. And so for billions of years, our planet managed to maintain the balance between the two, allowing life to evolve. Why and how? That's of course a question nobody can answer, but that's why the scientists are trying to figure out if something like this can also happen somewhere else out there. For example, it might have happened on Venus back in the days, there might have been even life there, and so maybe it can exist somewhere else. And so one important discovery from the study are these very specific detections and these very specific signatures of the clouds produced during this period. These very unique water clouds produce very specific patterns that could be detected with modern telescopes. And so by observing a planet and its atmosphere, it might become possible to determine if this is happening somewhere else. For example, one of the planets in the TRAPPIST-1 system. We know that the closest two planets seem to have nothing on them, no atmosphere and no liquid water, but there are still 5 planets to go, and discovering something around those planets would be super exciting. Hopefully we'll get to hear more about this sometime soon from the James Webb. For now though, we don't really know what's going on there. With the other important discovery basically suggesting that it looks like our planet almost reached this point back in the days. The overall discovery here suggests that you only need about 47 degrees Celsius on average to start this irreversible process. And as I mentioned before, millions and even billions of years ago, the average temperature on the planet might have approached 40 degrees Celsius. Not so far from that limit, where it could have begun an irreversible destruction of everything on the planet. And that means that there were at least a few times historically when the planet was just a few degrees from beginning this really powerful process. If planet Earth was a little bit closer to the sun, or if the sun was just a little bit hotter, it would have started. But because we know it didn't, it just once again confirms that our planet is maybe just a little bit too lucky. Hello wonderful person, this is Anton, and today we're going to be discussing new discoveries in regards to planet Earth, or a potential resolution to one of the mysteries that's visible in one of the maps created by NASA, although invisible in most of the maps we're used to and most of the maps used at school. A map that you see right here. And this map shows us what's known as gravitational anomalies, or in other words, slight deviations from the norm when it comes to the gravitational field on the surface of the planet. And so even though on average you expect the gravity to be the same no matter where you go on the planet, in reality, depending on what happens underneath, the gravitational field does change by just a little bit. And back in 2002, NASA started a mission known as GRACE, Gravity Recovery and Climate Experiment. A mission involving twin satellites orbiting planet Earth that would measure minute deviations in gravity field in order to analyze and discover various water formations and water reservoirs on the planet, but eventually extended to study other things as well, including crustal deformations and even massive formations underneath the crust. And this mission was conducted for over a decade, allowing NASA to create a very accurate map of planet Earth when it comes to gravitational field anomalies. And some of these unusual anomalies we've already discussed in previous videos, although the most famous ones were usually referred to as positive gravity anomalies, basically where the gravity is higher than it should be. Intriguingly, the biggest positive anomalies on the planet are associated with what's known as LLSVPs, large low shear velocity provinces. You can find out more about them in some of the videos in the description, but in a nutshell, it's these really huge chunks that today the scientists believe might actually be the remnants from the ancient collision that created the Moon and modern planet Earth. So basically these are remnants of Theia. But if you look at the map of the planet, you'll also find that there are not just positive anomalies, there are also negative anomalies. Here's I guess the more detailed version of this map, available directly from NASA, that shows you most of these anomalies in different color. And so the blue patches, especially the one that you see right here, are various regions on the planet that do exhibit slightly less gravity than the rest of the planet. And though some of them are quite obvious, like this is the Mariana Trench, the deepest trench on the planet. Here's what it looks like in contrast to the largest oceanic range known as the Mid-Atlantic Ridge. These are basically underwater mountains that you would not be able to see from the surface. Some of these anomalies even today are still unexplained. Now here we're not talking about Himalayas, although it is actually related to this, We're talking about that blue patch you see in the middle. This is the so-called gravity hole, an unusual gravitational anomaly in the Indian Ocean that for the longest time has actually been completely unexplained. And unexplained for one reason. In pretty much every case, the negative anomalies are either the result of ocean trenches or a lot of other depressions in the landmass. For example, like the ones you see right here in North America, they were most likely formed by ancient glaciers that were pressing on the surface and squished it just enough to reduce overall gravity, or in some cases, the presence of some kind of a low-density formation inside the mantle resulting from the interaction of the mantle itself. But all of these anomalies so far had some kind of an explanation, usually related to the detection of something underneath that spot, or a result of very thin crust, like the one you see right here in Africa, that was caused by the continents being stretched by the mantle underneath. And so technically you can summarize all of this as 5 potential explanations, either the thinning or thickening of crust, mantle, or sometimes both. But the actual changes here are very minute. They would not be perceivable to humans, and they would actually not be detectable by anything other than very powerful instruments. Here the differences are basically as if the planet was maybe 100 or 200 meters higher or lower. Although here I guess a bit more explanation is probably necessary. These changes are measured in the unit known as gal, named after Galileo. 1 gal is equivalent to 1 centimeter per second squared, and technically the gravity on Earth is roughly around 976 gal, but it does change based on the altitude and based on the location. But here we're looking at changes in milligal, with the biggest change being 50 milligal, the smallest one being minus 50. And so that's basically just a decimal point that would be completely insignificant, but still observable and detectable with satellites, suggesting that something is definitely going on here. And it's this unusual formation in the Indian Ocean that's always been kind of confusing. Because here there are no ridges, this is actually all basically the same depth with a relatively similar structure of the ocean floor, and it also does not have any continents that are spreading apart, yet it's also the biggest such structure visible from outer space, or detectable by these satellites. And so this unusual gravity hole was always one of the biggest mysteries when it comes to gravitational anomalies. Here we're talking about an area of about 3 million square kilometers, with the center approximately 1200 kilometers southwest of the tip of India. And the only explanation that would make sense here is of course if something is happening inside the mantle underneath this spot. But what? And so to try to figure this out and to try to answer these questions, the scientists whose paper you can find in the description decided to rely on various computer simulations trying to recreate Earth in the last 200 to 300 million years, and to then see what actually evolves over time as the planet undergoes various geologic changes and as various plates interact, creating new continents and destroying some in the process. And following 19 different scenarios, 6 of the simulations seem to produce something very similar. They resulted in a gravitational anomaly that seemed to be produced by a low-density area surrounded by very large, hot plumes. Or to rephrase this, it seems to be a result of some kind of an ancient ocean sinking underneath and producing the low-density, low-gravity anomaly, but also surrounded by relatively large plumes of molten rock that are now rising at the edges where this ocean used to exist. With the exact explanation being as follows. It all starts approximately 120 million years ago. This is following a breakup of a very large supercontinent known as Gondwana. At this point, chunks of the continent start to create various smaller continents, with Africa and India separating from the rest and now traveling a little bit to the north. Actually, one of the best ways to imagine this, or to try to visualize this, is by using the link in the description with the visualization created by Ian Webster. And so here, about 105 million years ago, the continents start to slowly separate, and India that you see right here and Africa start to move in the northerly direction. But at this point, there's this really large sea, or I guess technically an ocean, that's known as Tethys. This ocean was located between supercontinents of Laurasia and Gondwana and existed for millions of years, much longer than most oceans on the planet today. But approximately 120 million years ago, things on the planet started to shift around. And so here's the planet approximately 90 million years ago, here's Earth when the dinosaurs perished, here's Earth 50 million years ago, and here's Earth 35 million years ago, when India has now rammed into Eurasian continent and has now begun forming Himalayas. And so as you can see, India advanced through this region really quickly. But as it did so, it sort of pushed on the ancient ocean forcing it into the mantle underneath the crust, and at the same time created a completely new ocean that we now refer to as Indian Ocean. Or in other words, it completely destroyed Tethys and instead formed a new region right here. And then within the next few million years, it moved a little bit to the north, with the planet now resembling this. And so the geologists behind this paper believe that these are remnants of the ancient Tethys seafloor, with the anomaly forming in the last 20 million years. With the anomaly taking shape in the last 20 million years, most likely because of the interaction between that ancient ocean and the hot plumes on its edges. With the study also suggesting that this is not something that's going to last for a very long time and will probably disappear within the next few million years. Although it's still not entirely clear if the simulated plumes from the study are really present underneath the Indian Ocean as implied. They haven't really been detected by any studies previously, but then again we do have certain plumes on the planet that really only make themselves known once major volcanic eruptions start. These types of plumes are responsible for the islands of Hawaii and also for massive eruptions in Iceland or in other locations normally in the middle of the continental plate. And so it could lead to some major volcanism in the next few millions of years if these plumes do make it to the surface. At least that's one of the implications from the paper. But the main finding is that, well, this anomaly is probably the remnant of an ancient ocean that existed for millions of years, making this the best explanation for this gravitational anomaly as of today. Hello wonderful person, this is Anton, and when it comes to the origin of life on a planet, there are plenty of different mysteries and plenty of questions that cannot be explained even today. But today we're going to be discussing this one mystery that's maybe not as well known, and the mystery that's still completely unresolved. Something that we've known about for almost 200 years, and something that affects all life on planet Earth. But something that could potentially be somewhat cosmological in nature. But in order for me to explain exactly what we're talking about, and to basically then talk about the new study, here I have to start with the really important part of history, and a very well-known Frenchman that most of us already know, the microbiologist Louis Pasteur, who's technically known as the father of microbiology, and whose name is associated with a lot of different things. I mean, one of them is obviously pasteurized milk. But back in 1848, he discovered a very unusual phenomenon that he could not explain right away. Here he was studying what's known as tartaric acid, and this is actually something you can usually find in grapes and, in his case, in wine. I mean, he's French after all. Now, because he was also good at chemistry, he was able to synthesize some of the tartaric acid instead of extracting it from, for example, grapes. Now, by itself, this was already a pretty big achievement, but what he actually realized when he looked at it through various microscopes and by applying polarized light is that for some reason, both solutions, despite being tartaric acid, were producing entirely different optical observations. Now, the synthesized version was not producing any specific effects and was for the most part neutral. But the acid that was extracted from the grapes ended up shifting polarized light by just a little bit, suggesting that the actual solution from the grapes and the solution produced in the lab was not the same. The synthesized and the natural solutions were producing different optical observations. But in order to figure out what's actually happening here, he then decided to crystallize these liquids to see if they're going to produce the same crystals. And they obviously didn't. They produced something that was a little bit different and something that possessed different effects. Eventually he realized that he discovered something that we never knew about various organic molecules that today we refer to as chirality. Some molecules of tartaric acid were left-handed, but some were right-handed. Today more commonly referred to as dextro and levo in organic chemistry. But more importantly, what he actually discovered was the biggest mystery of biology. The synthetic liquid that he created contained both left-handed and right-handed liquids in equal amounts. Kinda makes sense. But the ones he extracted from grapes and other stuff were basically all right-handed. The synthetic acid had two different crystals, but the acid from grapes only had one. And apparently at this point, this was his eureka moment. He exclaimed, "L'univers est dissymétrique." He discovered that life, for some reason, had a huge preference for chirality, or for the handedness of molecules. Now, in case you've never heard of this before, chirality or handedness applies to most of the complex molecules that can be constructed in 3 dimensions. So basically here you can produce the same chemical formula, but the actual molecules are going to be different. They're mirror images of each other. And because of this, they actually do not have the same effects. Moreover, it turns out that all sugars on planet Earth are right-handed, whereas all amino acids on planet Earth are left-handed. And they cannot be exchanged for one another because they will not have the same effects. And this biological chirality, for about 180 years now, has sort of remained as one of the biggest mysteries. One of the strangest properties of life on planet Earth that really doesn't make sense. Especially because, except for one exception with bacteria, no life on the planet can use left-handed sugars. Surprisingly, there is only some types of ancient bacteria known to us that can physically change left-handed glucose into right-handed glucose in order to be absorbed later on, but they cannot digest left-handed glucose no matter what. Which also naturally raises a lot of questions. So can other-handed life exist elsewhere? Can we actually have RNA and DNA that's entirely right-handed, creating an entirely different type of life that's technically mirror image of us? And the answer to that is yes. We just don't know if it can exist on planet Earth, and it's probably not going to survive here for one simple reason. It's going to have nothing to eat. It cannot use any resources produced by life on Earth because we are basically left-handed. Or our DNA and RNA are left-handed and our sugars are right-handed. Okay, I know it's a bit tricky and confusing, but that's basically how it is. And so even though both left-handed and right-handed sugars can exist in nature and are often created as both types, only right-handed sugars are used by life. And there's even evidence for chiral organic molecules in outer space in various nebula, although it's not clear which ones are more common. But for practically 200 years now, the scientists have been trying to solve this, and there are several sources for a potential solution. One of them is actually outside of planet Earth. By using organic samples collected from ancient asteroids, it could be possible to determine what sort of chirality is prominent here as well. One of the future studies of the samples from asteroid Bennu is going to be resolving one of these mysteries in the next few years. We don't really have the results yet, but they're coming soon. But the other way is by conducting various experiments here on planet Earth and trying to recreate this in a lab. So basically, can we actually create conditions where certain chirality takes precedence? And various experiments have been conducted in the past, with one conducted very recently. And so far, here are some of the potential explanations. The first one is, I guess, more or less simple. It could be an accident. Maybe sometime in the past, one of the molecules became more prominent and eventually became used by most of the life that was developing. Other one kind of disappeared. And though it's a simple explanation, it does kind of make sense. The other explanations actually rely on something from outer space or on various physical elements that were present on early Earth. For example, in some experiments, scientists were able to show that polarized UV light coming from the sun can increase the destruction of one type of a molecule compared to the other one, resulting in, for example, more right-handed compared to left-handed molecules. Likewise, certain studies suggested that by being in a certain location in a certain nebula when the planets were just forming, it's possible that activity from very powerful stars resulted in huge amounts of radiation that would then destroy certain molecules, which would actually imply that there are probably several stars with several planets that all came from the same nebular cloud that all probably possess these right-handed or left-handed conditions. Likewise, a study from 2020 that we've actually discussed previously with a video in the description suggested that cosmic rays, and specifically muons, are often magnetically polarized in such a way that they're going to actually show a little bit more preference for the electrons from, for example, right-handed molecules compared to left-handed, which would increase overall interaction and also mutation, as well as destruction of potential DNA. So basically, in this case, the cosmic radiation itself could preferentially affect right-handed molecules as opposed to left-handed, although other studies have also proposed this to be neutrinos and not cosmic rays. So these are obviously more hypothetical, and this would be very difficult to prove, but they still kind of make sense. But now we have a new proposition that's actually a little bit more exciting than the ones previously, and this one involves an actual experiment that even shows the creation of only right-handed molecules. As always, the study in the description. Here it involves what's known as riboamino-oxazoline, also known as RAO. This is a very important precursor to RNA and is also either left-handed or right-handed. Specifically, it ends up producing cytosine or uracil. But like so many other sugars, it can also produce crystallized particles and can thus be studied a lot easier. And just like previously with Pasteur's experiments, it produces either right-handed or left-handed crystals. Although in this case, unlike previous crystals used, this one we know is needed for life. But only one type can be successfully used by life to produce RNA molecules. And so intriguingly, the scientists in this case were able to grow very specific crystals by placing them on magnetite. And when placed on magnetite surfaces, for some reason, the crystallization of this molecule was always 100% producing left-handed amino acid, the one needed for life. But they also were able to then produce opposite molecules also with 100% success by essentially changing the spin alignment or magnetization of the active surface. With the main implication here being that all of this could have been because of magnetic particles that were present all over the surface of early Earth. As a matter of fact, magnetite is often correlated with the existence of early life on the planet, with the main implication being that life might have a preference for handedness because of magnetite and magnetic minerals in primordial times. Although intriguingly, the scientists suggest that none of this seems to work in liquid muddy conditions, but seems to mostly work on a rocky surface containing solid magnetite. Nevertheless, here the discovery is really exciting. It produces an experiment that's easy to replicate that creates chiral organic molecules using very similar conditions to primordial Earth, which by itself is already quite groundbreaking. But it's obviously just the first step in trying to figure this out. As a matter of fact, we've actually discussed previous experiments that try to create synthetic life on the planet using various sources from bacteria, and here it would be interesting to find out if someone could potentially create synthetic life that's entirely mirror to a typical life we find here, and then it would be interesting to see what it's actually going to do. Now, the expectation here is that it's probably not going to survive. It needs to consume mirrored food, it also needs to have all its sugars in mirror format as well, but on the other hand, it's unlikely to be affected by viruses which would not be able to connect to it. And so what exactly this synthetic mirror life would do on Earth would be a very intriguing question to answer. Although intriguingly, some studies even propose that maybe if such life actually occurs on the planet, it could completely take over everything. Mostly because this bacteria, if it found some kind of a food source, for example algae that can actually use sunlight, would suddenly find itself without absolutely any predators or any enemies. Nothing could consume it, nothing would want to eat it, which could potentially lead to a major disturbance of the food chain. And though it does make a pretty cool science fiction story, apparently it has been explored many times, including Star Trek, and more recently in the Fantastic Four. So this is definitely a concept that has been explored previously and scientists have thought about before, but it's not a concept that we still understand very well. But more intriguingly, when it comes to astrobiology, the scientists would love to find out, assuming that life exists out there, is life actually mirror anywhere else, or is it always going to have same handedness as life on planet Earth? And if so, why? Hello wonderful person, this is Anton, and today we're going to be discussing some additional discoveries and confirmations about the inner structure of our planet, planet Earth. Because it turns out, just like the scientists thought for about 20 years now, there is definitely another structure inside our planet that the scientists are currently referring to as the innermost inner core. Maybe not the best name, but that's the only name we have for now. And we've actually initially discussed some of these discoveries a couple of years ago in a video that you can find in the description, but the confirmation for all of this came very recently, only a few weeks ago, from this paper right here that you can find in the description as well. In this case, with the scientists relying on a completely new technique in order to investigate the inner structure of the planet and in order to discover what's going on the inside. And by using this extremely detailed observation based on the seismic activity on planet Earth, we're able to definitively see something on the inside. But I guess let's discuss this in a little bit more detail and also talk a little bit more about what this might mean for future research and what this means for planet Earth. But let's start with a bit of a history of how all of this started to begin with. Now, a lot of early research on planet Earth determined that there are definitely at least 4 layers. And actually by 1936, the scientists were pretty certain there is the crust, the mantle, the outer core, which basically produces the magnetosphere, and the inner core. With all 4 structures obviously interacting with one another, with the inner structures obviously creating a lot of effects on the surface as well. For example, one of the main reasons we even have the magnetosphere which obviously protects planet Earth, is because of the very specific type of circulation inside the outer core of the planet that churns around in just the right way to create these powerful effects. But the reason it's able to move around so much is actually because the inner core extremely slowly grows in size, cooling down, solidifying, and releasing heat and light in the process. And this heat warms up the outer core, generating the dynamo that then creates the magnetosphere. And so whatever happens inside the inner core is actually extremely important for basically the survival of life on the planet, which is really one of the primary reasons the scientists want to understand a little bit more about how all of this works. Obviously, this is not something that developed on other planets very well. For example, both Mars and Venus, despite relatively similar composition, do not possess the same effects. And so in order to understand the habitability of planet Earth, the scientists absolutely have to study the inner core in order to see how it grows, how it changes in time, and what exactly it does to the rest of the planet. But obviously, studying the inner core is extremely challenging. There's really only one known technique we have that allows us to see the insides. It relies on detecting various very powerful seismic waves, or essentially earthquakes, that go through the entire planet, changing their direction and changing their speed in the process. Because as the waves pass various structures, they tend to change their direction, they also tend to change their speed, which can then help the scientists figure out where the boundaries lie, but more importantly, what sort of a density and composition the inner structure has. But one of the main reasons it became so much easier today is really because of the number of various data collection centers, or seismic monitoring stations, that now exist around the globe, which in essence allows the scientists to scan the internal structure of the planet with much higher resolution than was ever possible before. But even 20 years ago, back in 2002, the scientists looking at some of this data already discovered something a little bit unusual. Two scientists, whose paper you can find in any description, tried to explain the discrepancies they were finding in the travel time of various wave models as a potential new structure inside the inner core. Something they believed was about 300 kilometers in diameter, so not really that big compared to the rest of the planet, but still big enough to present a bit of a difference, with additional papers from other scientists potentially confirming their findings and suggesting that it was maybe just even a little bit larger, at 400 kilometers. But anyway, this kind of laid the groundwork for what became a 2-decade-long study trying to figure out if there's really something inside, or if it was just some kind of a phenomenon we could not understand. And 2 years ago, another study, looking at various evidence from powerful earthquakes, discovered even more evidence that there's definitely something on the inside. Something that was even more dense than the core we're aware of, and very likely containing mostly iron, or essentially the innermost inner core, the fifth official layer of the planet. And so through years and years of investigation and analysis, and by combining data from a lot of different earthquakes, in this case mostly from Alaska, which does tend to have a lot of powerful earthquakes, the scientists were able to actually find something unique that was never seen before. As some of these seismic waves passed through the core of planet Earth, many of them started to reverberate inside some kind of a structure on the inside, and in some cases they bounced around at least 5 times. Now sometimes the scientists have detected a reverberation of 2 times, but 5 times is basically unheard of. And it really just meant one thing, that there was something on the inside that caused the waves to kind of echo around, kind of like inside an empty room, with all of these echoes or reverberations eventually being detected by other sensors, with the earthquake that happened in 2017 on the Solomon Islands contributing the most. This was a 7.9 earthquake, so it did create quite a lot of powerful waves that bounced around the inner core several times. And this data confirmed the structure, but it also allowed the scientists to almost definitively determine the size of the structure. It seems to be much larger than originally thought, maybe 400 miles, approximately 640 kilometers in size, which is twice as big compared to the original prediction from 2002. And although it's always been believed that the inner core is made out of some kind of a iron-nickel alloy, the scientists believe that the innermost inner core is almost entirely iron. And by itself, this already presents us with a very interesting mystery, and something that currently the scientists cannot explain. One suggestion here is that Earth might have experienced 2 distinct periods during its early development that produced 2 separate cores on 2 different occasions, and possibly for 2 different reasons. At the same time, the properties of this innermost core suggest that there is some kind of an unknown phase change of iron that must happen on the boundary of these 2 cores. the iron core on the inside and the iron-nickel core on the outside go through some kind of a change, possibly due to temperature or pressure, in order to form these two distinct structures on the inside. But because it's also much larger than the scientists originally believed it to be, it also probably has quite a lot of effects that we've never really considered before. For example, one of the recent videos about the core presented a new paper where the scientists tried to explain why the rotation of the core itself seems to occasionally change with time. In other words, the spin of the core seems to oscillate going back and forth a little bit faster or a little bit slower than the rotation of the planet. At the moment, it's unknown why it does so, but there's maybe a very good explanation hiding somewhere here. All of this could be due to the innermost core that's somehow causing these oscillations, which then reverberate through the entire planet. It's also quite possible that it's actually because of this structure that we even have the outer core that then produces the magnetic field. And more importantly, it suggests that the early Earth must have gone through some unusual period that resulted in the formation of these two separate layers. Something that some other planets might have not gone through, which explains why they're so different. But since its diameter is about half the diameter of the inner core, it most likely has quite a lot of effects which need to be investigated in future studies. So obviously at the moment there's really no suggestion on what exactly this does to the rest of the planet and what effects it might have on the other cores or even the mantle or even the crust of the planet. So this is still a completely new discovery. But in the last few years, this is not the only unusual discovery about the core of the planet, and even not the strangest one. Because once again, since we have so many seismic detectors on the planet now, with many listening at all times, the scientists have started to discover some really cool things about the internal structure of the core, with many discoveries listed in the description below. For example, one of the recent discoveries from a couple of years ago has also suggested that for some reason, the inner core seems to actually grow differently depending on the side. It seems to grow faster on one side compared to the other. This was a pretty big discovery and it definitely has quite a lot of effects on the rest of the planet, and this is definitely something I want to follow up on in the next few years as the scientists discover more. At the same time, the scientists have learned that quite a lot of ancient helium is leaking from the core of the planet, potentially producing some other effects as well. But intriguingly, one of the best ways for us to learn about the core of planet Earth is by actually launching a spacecraft to another body. In this case, the asteroid 16 Psyche, which NASA is supposed to launch sometime in 2023. You can learn more about this particular mission in one of the videos in the description. And so because it's believed that Psyche might represent some kind of an ancient undeveloped iron body that was supposed to become a core of an ancient planet, by learning more about its structure, its composition, and of course its formation history, we might be able to understand what happened to planet Earth a long time ago. And thus figure out why planet Earth has conditions that planet Earth has, yet Mars, Venus, or even Mercury do not. What exactly happened to planet Earth to make it habitable and to make it perfect for life? Something we're going to be discussing more in some of the future videos as well. Anyway, on that note, well, pretty exciting, a great confirmation of a null theory, and of course an official reason to rewrite a lot of high school books, because it looks like Earth has 5 layers, not 4. Although that inner core definitely needs to have a better name. Innermost inner core just doesn't really roll off the tongue very easily. So let's just give it an easier name. I'm gonna call it Bob. Alright, let's discuss extinction. Extinction of all mammalian life, including of course us. But in this case, this extinction will probably not matter much to us because it's going to be happening in the far, far future. Nevertheless, trying to figure out when complex life goes extinct on planet Earth might actually help us understand a few other things in the process as well. So, hello wonderful person, this is Anton, and in this video we're going to be discussing a relatively recent study that in essence confirms that at some point in the future, most, if not all, mammalian life, including future humans, are going to go extinct and will not be able to survive on Earth no matter what. But I guess more surprisingly, they actually discovered that it might happen a lot sooner than anyone believed. And though by then we expect most of the complex life to potentially evolve into something entirely different, at some point in the future, the physical conditions on the planet are just going to be too extreme for any complex biological life, at least based on the current understanding of biology. And so let's discuss this particular study, relatively recently published in the Nature magazine, that to some extent predicts the demise of mammalian life on planet Earth and provides really intriguing explanation. And so what exactly is this paper all about? Well, it's really all about predictions on what happens to the planet every few 100 million years. Based on a lot of geological evidence, we know that once in a while, all of the continents on the planet create what's known as a supercontinent, which is obviously the result of what's known as plate tectonics, previously known as the continental drift. And the last time it happened was most likely approximately 300 million years ago. This was the supercontinent we refer to as Pangaea, and you can actually see some of the previous ones in one of the links in the description. So as you can see, approximately every few 100 million years, we actually get new supercontinents forming because of the plate tectonics. And based on the calculations we have today, it's most likely going to happen again anywhere between 100 to maybe 250 million years in the future. With one of the best known models, usually referred to as the Pangaea Proxima or the next Pangaea, although more commonly known as Pangaea Ultima, the next supercontinent that's expected to happen possibly in the next 250 million years. Once again based on the observations of how continents move around and what usually happens when they start colliding and interacting with one another. And so here if you look closely you'll see the outlines of the South and North America, we have the leftovers from Africa, and of course Europe and Asia here as well. Although here it's possibly going to have some kind of a large ocean or some kind of a large sea in the middle, something that we have seen before in previous iterations of previous supercontinents. Although once again this is based on geological evidence, not so much on physical observations. But the prediction model based on computer simulations right now is pretty strong. Although here a very important side note, there are other predictions and other simulations as well. We have a prediction for something referred to as Amasia, something that might actually even form within the next 100 to 150 million years. We have the so-called Novo Pangaea, although here it's based on a much older model, and we have something known as Orica. Here is sort of the video showing us how all of this might assemble over time. And so quite a lot of these models exist, but most of them basically end with the same result. You do get some kind of a final supercontinent at the end that remains as a supercontinent for at least 100 million years, possibly longer. And the thing is, when supercontinents form, they all tend to have very similar climatic changes. Based on the studies from Pangaea, which existed 200 to 300 million years ago, we know that things generally tend to get much hotter. And really for one reason: carbon dioxide. Because the continents join together and because there is not as much geological recycling, the CO2 levels in the air rise dramatically all the way to something like 2000 ppm. At least 5 times higher than right now, which is exactly what's observed in various rock deposits discovered during the period when Pangaea was around. And this generally increases the average temperature by at least 10 degrees Celsius. On top of this, the sun is also slowly growing a little bit bigger and a little bit hotter. And by the time that the supercontinent is essentially complete, the emissions from the sun are going to be approximately 2.5% higher. It doesn't sound like a lot, but it's enough to dramatically shift the conditions on the surface. With all of this dramatically shifting the global climate and very likely creating unbearable conditions on the surface. At least unbearable for mammalian life. Here, the mean temperature is expected to be approximately 46.5 degrees Celsius, 116 Fahrenheit. In comparison, the mean temperature on Earth today is only about 15 degrees Celsius, 30 degrees Celsius lower. And at these temperatures, most complex modern life would have a lot of trouble surviving. The vast majority of proteins, for example, would be completely denatured, resulting in the failure of metabolism or photosynthesis. And that means that mammals, that essentially dominated the planet for the past 55 million years, mostly because of their ability to adapt to many different climatic conditions, will very likely reach the physical limit when the Earth becomes just a little bit too toasty to survive. Although technically some of the first mammals appeared approximately 300 million years ago, potentially during the existence of Pangaea. And so maybe there is a way for some smaller animals, the ones that can burrow and hide inside somewhere, to survive on this super hot Earth. But it's unlikely that the mammals are going to be dominant, and it's more likely that someone else that's able to tolerate such heat is going to become the dominant class. And even though mammals were able to survive most extinction events in the last 300 million years, the simulations from this paper suggest that by the time the supercontinent finishes forming, most of it is going to be just way too extreme. with something like 8% of terrestrial world still providing some support for complex mammalian life. And so by the time that the CO2 levels are about 3 times as high as they are today, most of the planet becomes completely uninhabitable. Or at least uninhabitable for anything living on the planet today. And although we knew that this is going to happen eventually, previous predictions suggested that we might have at least 1 billion years. Turns out that it might happen much sooner. Anywhere from 100 to maybe 250 million years, depending on which model of supercontinents is more likely to be correct. Now this one here suggests 250 million years, and that's the one that most scientists currently agree with. You can find the simulation in the description below. But it's unlikely to happen within the next 100 million years. In terms of our geological understanding, we know supercontinents will not be forming for at least 100 million years. So mammals definitely still have some time. And interestingly, quite a lot of studies suggest that evolution is not going to be fast enough at helping animals adapt to these new extreme conditions. And so a lot of the adaptation techniques and a lot of proteins that we use are just not going to be able to function in conditions that are that hot. Or at least that's one of the preliminary assumptions. Because as Jurassic Park taught us, life finds a way. There's still a chance that maybe some mammals might return back to water, just like dolphins and whales did back in the days, and might adapt to survive in the water instead. Although here the water is also going to be pretty hot. Likewise, smaller burrowing animals might essentially survive by switching to the nocturnal lifestyle while spending most time underground. And even though most of the surface might resemble something like this, essentially being a humongous desert, mostly because it's believed that the weather system is going to be completely disrupted by the existence of the supercontinent, essentially drying out forests completely and removing most of the vegetation from the surface. Despite of this, some animals will probably still find a way. We obviously have no idea how or what sort of animals, but chances are they'll develop some strategies surviving for millions of years afterwards. And in this case, one intriguing question is, so who's going to dominate the planet? What sort of an organism? Is it going to be reptiles again? Is it going to be some new species that we cannot imagine? Or is it going to be something else that already exists and is just waiting for its time to shine on planet Earth? So definitely quite an intriguing study. At least in terms of understanding the future of planet Earth and where life on planet Earth might be headed. But I'm sure there's going to be another study that's going to be exploring this even further or potentially discover something else super interesting when it comes to the planet Earth in the next billion years. And in case you're wondering when we actually think all life is going to go extinct, current predictions based on how the sun changes over time suggest that the sun actually increases in luminosity by approximately 1% every 100 million years. And so in the next 1 billion years from now, it's going to be about 10% more luminous, delivering so much heat to the surface that it actually has a very high chance to start what's known as the runaway greenhouse effect. Basically, that's what happened to Venus billions of years ago. And so there's a slight chance that this might happen to Earth in the next 1 to 2 billion years from today. At least that's one of the predictions we currently have. None of this is currently super clear, and all of this is just based on simulations and the current understanding of the planet, but all of this might change in the next few years. Hello wonderful person, this is Anton, and today we're going to be talking about planet Earth. Or actually about a recent announcement in regards to the change in the rotation of the core of our planet. With a lot of articles kind of making a somewhat unusual suggestion that the core reversed its rotation, which as you can imagine is kind of incorrect. And so in this video we're going to be discussing what exactly happened to the core of our planet, what the scientists have discovered in this recent study, that as always you can find in the description below, obviously how they found it, and why none of this is really that exceptional, unusual, or unexpected. As a matter of fact, we've discussed a lot of this in some of the previous videos. But I guess first, a quick reminder about the structure of planet Earth. Most textbooks today will present us with something like this. We have the crust on top, the mantle right beneath it, the outer liquid core, and the inner solid core. Although even this is somewhat refuted today, as the scientists in one of the recent studies, that as always you can find in the description, discovered that there might be another structure within the core that we didn't really understand before. So there might be actually 5 different layers. But the deepest layer, and the one that's most mysterious, is of course the inner core. The super hot, super pressurized, solid ball of metal That's about 1200 kilometers across, represents 20% of the Earth's radius, and is actually even smaller than the Moon, about 70% the Moon's size. And this unusual structure that's almost entirely made out of iron and nickel actually has its own rotation that is somewhat independent of the rest of the planet. Something that was actually only discovered back in 1996. You might actually want to check out one of the previous videos in the description that mentions something else we discovered about the outer core of the planet that to some extent also surprised the scientists. Either way, back in 1996, this study right here that you can find in the description definitively confirmed that the core has its own rotation that's not necessarily aligned with the rest of the planet. But prior to this discovery, the scientists actually believed that the core was almost not spinning at all, or that a single revolution of the core might take anywhere from 400 years up to even 1000. And so the assumption here was that the core was basically doing its own thing, with most of this driven by the balance between electromagnetism from the outer core and the gravitational pull from the rest of the planet. But here there's a really important clarification. It doesn't mean that the scientists thought that the core itself is completely stuck and does not rotate at all, whereas the rest of the planet just orbits around it. Instead, what the scientists believed is happening here is that the core might actually rotate a little bit slower, or even a little bit faster, than the rest of the planet, potentially completing a single rotation every 400 years. And that's compared to the rest of the planet that was also rotating as well. And so in other words, everything here was still rotating all together. The outside surface, and the mantle, and of course both of the cores. It's just they were doing it at slightly different times. But more recently, in the last decade or so, since 2009, the scientists started to discover something unusual about the inner core. It started to dramatically slow down its rotation. And even though initially it might have been rotating a little bit faster compared to the surface of the planet, it now appeared that it basically slowed down to the point where it ceased to rotate at all. Once again, compared to the surface. If you were to look from the outside of the planet Earth, it would still be rotating, but in this case at the same velocity as the rest of the planet. So it didn't really stop completely. But these new observations also suggested that it didn't just pause, it was also turning back, or essentially it was rotating slower than the rest of the planet, by a tiny amount, but visible nevertheless. With all of this, very likely some kind of an effect caused by the gravitational interaction between the rest of the planet and the core itself. Also very likely because of the magnetic fields of our planet generated by the outer core. Although here the scientists discovered that this might not be a single event, this actually might be some kind of a pattern that repeats over time. Or in other words, that the rotation of the core seems to oscillate every few decades, slowing down, stopping, reversing and accelerating with a multi-decade long timescale. And in this case, it was actually the same scientists that discovered this. The same scientists that published the paper back in 1996. And they did so by tracking seismic wave readings from various repeated earthquakes, sometimes known as doublets, that traveled across South Atlantic to Alaska between 1967 and 1995. But also looking at some of the recent results from recent observations as well. So here we can see that prior to 2009, the rotation speed was a little bit different to what we observe after 2009. And overall, it does create a kind of oscillation with a period lasting approximately 65 years. Now obviously this is using some of the older data that might not be as accurate, but nevertheless the actual results are quite interesting and quite intriguing. It basically shows us that first of all, the inner core rotation was consistent between the 70s and early 2000s, and then started to change dramatically, stopping completely in 2009-2010. But prior to this, during the 60s and the 70s, it might have experienced something similar, although maybe on a much smaller scale. Here there's just not enough data to determine exactly what happened. But it does imply that there might be a cycle or some kind of oscillation driven by external effects from the magnetic field and possibly gravitational interaction with something else. But I guess the obvious question to ask here, does this have any effect on what's happening on the surface? Or to rephrase this, should we be worried in any way? Well, pretty much nothing here suggests anything cataclysmic is about to happen. As a matter of fact, it probably has absolutely no effect on the surface. For example, this graph right here actually shows us that right now, the core is almost entirely in sync with the rest of the planet compared to several decades ago, which is unlikely to affect the life on the surface. It's not going to increase the number of earthquakes, it's also unlikely to increase any kind of other geological activities including volcanoes, although it would be really interesting to find out if it has any effect on the magnetosphere of the planet. Since a lot of these effects are believed to be both gravitational and electromagnetic in nature due to the interaction with the outer core, it would be interesting to find out if there are any patterns or any oscillations in the magnetic field as well. At the moment, this is not known. Although here the scientists do suggest that there might be some coincidental correlation to other periodic changes on Earth, including the tiny variations of the length of the day on Earth and the slight changes in the magnetic field. We actually discuss some of these mysteries and some of these discoveries in the videos in the description, which of course suggests that there's definitely some kind of oscillation and some kind of a pattern that seems to repeat every 60 to 70 years and potentially has very minute effects on the rest of the planet. And so of course the next important question here would be what other effects this might have. We know that there are other patterns and other oscillations on the planet in regards to sea level and even the global mean temperature, but at the moment nobody really knows if any of this is connected just yet. A single Earth day technically contains 86,400 seconds, and up until a few decades ago, this was always believed to be the case. But since then, our ability to measure time has improved so much that now it's no longer the case. The scientists had to propose a new concept, what's known as the leap second, a 1-second adjustment that happens once in a while when the Earth's rotation slows down by just enough to make the calculations of time on Earth no longer accurate enough. And all of this is actually because of the advancements in various measurements using distant objects like quasars, which are used for extremely accurate measurements of time, with a lot of modern satellites, including GPS satellites, directly relying on all of these calculations and all of these adjustments. With some of the most recent observations and calculations on the planet discovering some other mysteries in the process. For some reason, the length of the day on the planet has been increasing, and at the moment nobody explained why this is happening. But let's discuss this in a little bit more detail. First of all, we know that the moon itself has always been slowing down the rotation of the planet. It's been doing this for billions of years. Originally, when the moon was just created, a single rotation on the planet was approximately 6 hours long. But because of the moon's pull on the planet, and obviously the Earth's pull on the moon, Earth's day changed from 6 hours down to 24 hours that it is today. And modern calculations suggest that the moon adds approximately 2.3 milliseconds every 100 years because of its gravitational influence on the planet. And so this is a pretty slow process that doesn't really affect much in terms of scientific calculations or measurement of time on the planet. Another process has way more influence, something that began approximately 20,000 years ago. With the end of the last glaciation or ice age approximately 20,000 years ago, the Earth started to speed up. And that's because the ice caps that melted in the last few thousands of years reduced the overall surface pressure, which forced some of the mantle from within the planet to move toward the poles, essentially redistributing the weight and slightly increasing the rotation speed. And this shortens the day by approximately 0.6 milliseconds every 100 years. Things like earthquakes also influence the rotation as well. For example, the 2011 earthquake in Japan very likely sped up the rotation by about 1.8 microseconds. But more importantly, things like tidal variations and also various weather effects on the planet tend to redistribute the water, which then actually changes the rotation as well, with the variation here also being in milliseconds, but it can either speed up or slow down the rotation. Although some of these variations do have a very predictable period. In this case, there's a known period of at least 18.6 years. All of this due to lunar tides. We've actually explored a similar concept in one of the previous videos that you can find in the description. And so in general, a lot of different weather patterns can actually affect the motion of the atmosphere on the planet, which then affects how fast the planet spins. And these atmospheric effects are even more dramatic on planets like Venus, where the atmosphere caused the planet to completely slow down. The rotation on Venus is in hundreds of days. And that's because the atmosphere here is much thicker. But on Earth, rainfall, snow, and a lot of other interaction on the surface will often affect the rotation of the planet. But as I've explained in the video about quasars that you can also find in the description below, today all of the time calculations involve the quasar map that you see right here. This is a super precise map of the location of several major quasars that's used in combination with various radio telescopes to precisely calculate the Earth's rotation and to then also precisely calculate time. And when used in combination with modern atomic clocks, it often allows us to also precisely calculate by how much the rotation of the planet changed. And turns out, June 29th of 2022 was so far the shortest day on record. Even though the opposite was happening in the last few years, the days were getting a little bit longer. And at the moment, nobody really knows why this happened. The most likely explanation is the sudden appearance of a lot of extreme weather effects in various locations on the planet. For example, here in South Korea, we've actually experienced the heaviest rain ever, with something like 14 centimeters of rain every hour, for at least a few hours. You can actually Google rain in Seoul to see some of the craziest pictures ever. But other regions experienced other types of weather patterns, and in a sense this could have influenced the rotation of the planet. This could also relate to the back-to-back La Niña events that happened in the last couple of years, which tend to have dramatic effects on the entire planet, and we've also discussed this in a previous video in the description or somewhere right there. Or it could be the melting snow caps, or even the Tonga eruption that occurred in January of 2022. In other words, at the moment, it's a bit of a mystery. As a matter of fact, weather here could be completely unrelated. Maybe it's something to do with the phenomenon known as Chandler wobble, which is believed to have a period of 433 days, and is related to slight deviations of the rotation compared to the solid crust on top. So at the moment it's currently unknown. But what is known is that it does have an effect on our daily lives. It might not seem like much, it's only milliseconds, but every few years for the past few decades, the scientists, because of these super accurate observations and calculations, had to introduce the idea of leap seconds, with the first leap second being added on the January 1st of 1972. And here's actually a graph showing us an overall deviation of the day length compared to the standard that we expect, which is 86,400 seconds, with the last second being added right here on January 1st of 2017. But here's the thing though, and this is maybe something that most of you didn't realize. Because of modern technology and because of modern computers, this actually affects computers quite a lot. As a matter of fact, the addition of a leap second in 2012 ended up taking down several major websites, including Reddit, Gawker, and even Australian airline website Qantas. Whereas this article from 2017 explains why Cloudflare was also taken down by the leap second that happened in 2017. And because of this, several technology companies, including Facebook, have actually been advocating against introducing new leap seconds because they're afraid it's going to take down their websites as well. And actually not just websites, but entire networks that might be dependent on precise timekeeping that's not used to leap seconds. Although right now, pretty much most of the modern hardware and software is already used to having these leap seconds, so it technically should not be causing any problems. The problem is, we don't really know what's going to happen to the rotation of the planet in the next few years, and if it sort of continues the same trend, the scientists are actually thinking of introducing a negative leap second, basically a -1 second. If you look here, all of the leap seconds so far have been positive, and a negative leap second is going to create a major issue. Or it might, we don't actually know. Some computers might adjust to it pretty quickly, but some other ones, especially on older hardware, or the ones where some of the network administrators might not be ready for it, might actually end up creating a lot of chaos. And because so far the lengths of the day have actually been increasing and getting longer for reasons unknown to us, despite the fact that we've just experienced the shortest day, it means that this negative leap second could become a reality after all, because as you can see from this graph, it's anyone's guess right now where the rotation of the planet goes. Because of the dramatic climatic changes and mixed with a lot of unpredictable events, it's quite possible that the days might get longer and longer, which might result in the introduction of that negative leap second. But interestingly, leap seconds were never really that disruptive. It really only became a problem in the last decade because of the advances in technology and our dependence on a lot of internet and network activities. And so next year, the ITU, International Telecommunication Union, might actually announce the cancellation of leap seconds once and for all, and potentially adopt something a little bit more dynamic, such as the idea proposed by Google known as the leap smear, a kind of a shorter adjustment that instead of introducing 1 second, introduces time change in much shorter increments. Which of course means that, because of the internet, we might actually have to completely change the way we measure time as well. Although I personally find it a little bit ironic that it's actually Google that's possibly going to influence all of this. It really shows you how much power this company has over everything. I mean, technically, you're sort of watching this because of Google as well. And so at the moment, nobody really knows where all of this goes. We might be able to find an acceptable way to change time in the future, or we might experience a negative leap second, which might end up creating a lot of chaos and problems for a lot of companies relying on very accurate time. I mean, we already know that some of the stock markets have actually experienced crashes because of leap seconds, so I guess only time will tell how the scientists decide to resolve this. But for now, I guess the biggest mystery is, what exactly happened this year? Why did Earth experience the shortest day? So approximately 66 million years ago, our planet has gone through a major climatic change. A result of a visitor that impacted the planet suddenly changing the climate for the worst. But in the last 65 million years, there actually have been quite a few other periods when the climate changed for one reason or another. And in most of these cases, we actually still have no idea what exactly happened and why the planet changed so much. But based on a lot of different fossil records and a lot of different analysis of things like ice cores, modern studies have established that the average temperature on the planet has never really remained the same for a very long time. But there are specifically several periods that are exceptionally intriguing. For example, right here you can see that there was a major glaciation of Antarctica, which then disappeared for some reason a few million years later, just to reappear approximately 12 million years ago. But at the same time, the first few million years after the impact that killed the dinosaurs, the temperature on the planet for the most part was a little bit toasty. On average, it was actually several degrees higher than today. But when you look at this graph, there is one spike that really stands out. PETM. Paleocene-Eocene Thermal Maximum. A still somewhat unexplained event that approximately 55 million years ago suddenly increased the temperature on the planet by about 5 to 6 degrees, causing the extinction of at least certain organisms, but more importantly, sort of showing us what happens if there's a sudden increase in levels of carbon dioxide in the atmosphere. Because all of the modern studies established that there is a very high correlation between high levels of CO2 during this time and high temperatures. But the levels were much higher than today, and we'll discuss this near the end of the video. Because what's actually interesting here is that this release of CO2 took approximately 20,000 to maybe 50,000 years in total. But once the CO2 was in the atmosphere, these relatively high temperatures lasted for about 200,000 years. The global average was increased by 5 to 8 degrees Celsius. Yet, mysteriously enough, even today it's not entirely clear what actually happened here. It's not clear if this was once again a result of a major collision, a result of some kind of a orbital forcing, or basically one of the Milankovitch cycles becoming too extreme, something related to the sun, or a major dramatic release of methane similar to what's happening today. With the only thing being clear is that there was definitely a major carbon emission based on the spike of carbon-12 recorded in various plankton organisms such as foraminifera you see right here, that actually increased in numbers during this time and dramatically increased the number of carbon-12 recorded in their shells, implying that there is definitely a very strong correlation between carbon and the temperature. But up until recently, it was not clear what may have caused this. And now we have at least one major study that, as always, you can find in the description below, that provides us with very specific answers, very strong evidence, and even to some extent explains what must have happened afterwards. Because if once again you look at this graph, you'll notice that suddenly the temperature actually starts dropping, with the planet cooling down even more, reaching the temperatures we have today, and entering what's known as the Ice Age. And so, hello wonderful person, this is Anton. Let's discuss some of these new discoveries and what all of this might mean, focusing on the most likely explanation for what must have happened 55 million years ago. And as you must have read from the title already, it was most likely volcanoes. But not your stereotypical volcanoes that we usually see once in a while. Here we're talking about a major basaltic shield volcano that was tremendously large in size. Here is roughly the area of this volcano, and it basically stretched all the way from Greenland down to the United Kingdom and all the way east to Norway, the large area known as the North Atlantic Igneous Province. And this particular igneous province is actually responsible for some iconic structure in the UK, such as the Fingal Cave or the Giant's Causeway. These were created around the same time and represent the edge of this province. There are even major volcanic structures visible in Scotland, all created around the same time. But the thing is, this was always the biggest suspect for this particular event, it's just there was never really enough evidence. And looks like now the scientists managed to find just the right location to try to prove this once and for all. In this case, focusing on the location in Denmark that was not part of this volcanic eruption, but turns out has quite a large amount of deposits that seem to be visible from around this time and were most likely the result of major explosive events that suddenly released huge amounts of materials, spreading it all across Europe, forming these huge deposits over time. And so, completely by luck, one of the sections in Denmark became exposed over time, and it's now actually possible to study all of this by directly looking at these formations in a location known as Fur in Denmark. And turns out, hundreds of different ash layers can be actually discovered here that will be impossible to explain unless something massive happened during this time, something that would definitely change the climate. But the question is, how do we know it's a volcano? Well, here this is where the analysis had to involve chemical composition and various anomalous elements. In this case, these are known as volcanic proxies, so things like, for example, osmium and things like mercury, which seem to be highly elevated in these deposits. These are actually extremely similar to what we usually find in modern volcanoes as well. And furthermore, lithium and osmium abundance indicates that during this time there was a really large amount of weathering and huge amount of erosion, and also extremely active hydrological cycle. In essence, confirming very high temperatures, very high levels of CO2, and a major dramatic change of climate on the planet. Although in this case, all of this volcanic rock would then also accelerate CO2 reabsorption, resulting in a major drop in temperature relatively quickly as well, which is most likely why we get this unusual spike. First, the temperatures jumped dramatically as the CO2 was released, and then the temperatures dropped as soon as CO2 became incorporated into various volcanic rock. Although here it's important to note that the evidence from Denmark only shows us some of the most explosive events that happened during this volcanic activity. And it's quite clear that all of this was happening for millions of years. As a matter of fact, it probably started at least 64 million years ago and ended approximately 54 million years ago. So it was active for about 9 million years, with the peak activity happening 56 to 54 million years ago. And so during this time, approximately 1 million cubic kilometers of magma was probably released, in the process unleashing approximately 35 trillion tons of carbon. And the calculations from this paper suggest that the total levels of CO2 in the atmosphere was anywhere between 840 to maybe 1600 parts per million, with this raising the temperatures by at least 5 degrees. Now, today's levels are obviously much lower, in this case approximately 418 ppm, that's when I'm making this video, but one of the main reasons a lot of scientists want to study PETM period, or this unusual spike in temperature, is really to understand what effect CO2 might have if we basically keep releasing CO2 in the atmosphere for the next few hundreds of years. And so according to calculations in this case, it might take humans hundreds of years of modern CO2 production to try to reach the same levels. But that's not really the main point of the paper. The main point is to try to understand the connection between CO2 and the climate change on the planet, while also figuring out exactly what it does to the planet when it does happen. For example, here's a map showing us what the surface probably was like during this period of time. You can actually explore it a little bit better by yourself by using one of the clue simulations from Ian Webster that to some extent shows us what the planet was like back in the days. As you can see, no ice pretty much anywhere, and lots of water everywhere as well. But what's actually really unusual during this period is that change of water levels and the overall change in the North Atlantic. During this time, North Sea was actually completely cut off from North Atlantic, forming this unusual region you see right here. And all of this only took approximately 12,000 years. And there's actually something really unusual that happened during this period, pretty much during this PETM period, which lasted for possibly millions of years. When the North Sea was completely cut off, it created a very strange subtropical environment that actually became paradise for one type of a plant. The plant you see right here, Azolla folliculoides. Now this is a type of a fern that grows in the water that has a very unique property of absorbing CO2 to extreme levels. As a matter of fact, it's one of the biggest CO2 sinks on the planet. And based on a lot of fossil records from North Atlantic, in the last couple of decades, scientists discovered something really strange. During this time, pretty much the entire North Sea was covered in this unusual plant for practically millions of years. It most likely peaked around 49 million years ago and is known as the Azola event. And so this whole region was covered in these unusual plants for a very long time. And it's mostly because this was an isolated region and it created perfect conditions for these unusual plants. But because there are such strong CO2 absorbers, they basically kept absorbing CO2 from the air for many thousands and millions of years. And so if we come back to this graph, you'll notice that approximately 49 million years ago, suddenly the temperature started dropping more and more, at some point reaching what's known as Antarctic glaciation. And so one of the modern explanations for what must have happened back then and why the planet suddenly started cooling down so much, eventually entering the Ice Age, is actually because of this unusual event involving these very unusual plants. Here's actually roughly what they look like on the surface. And so it's quite likely that this very unusual aquatic fern reduced the CO2 levels quite dramatically over a period of about 800,000 years, changing the planet from greenhouse Earth to essentially icehouse Earth, eventually transforming planet Earth into something a little bit more similar to what it is today. Although since then the temperatures have dropped even more for reasons that are still unknown to us. Which I guess to some extent is also good news for what's happening to the planet today. No matter what happens to humans or our activity, at some point the planet is going to find a way to recover everything, even if we might not survive the actual event. Now that's not really the main point of the video. The main point is that, first of all, Earth always finds a way, and second of all, very extreme events like PETM tend to lead to other events, such as the Azola event, that basically counteract everything, producing opposite effects. With all of these, of course, being really exciting and very interesting discoveries, just in regards to our understanding of how planet Earth works and how the biosphere tends to take care of everything eventually. With all of these records, then captured by various miniature organisms that turn into tiny sediments, serving as a kind of a record for what happened to planet Earth. But exactly where all of this goes in the next few millions of years, at this point, nobody knows. As a matter of fact, we even have no idea why this particular period that you see right here, known as Quaternary period, essentially has these ice ages that seem to have a cycle that changed even more a million years ago. And we actually recently talked about this because it was discovered that during this period, humans could have gone extinct. Approximately 4 years ago, there was a major discovery of an exciting crater in Greenland, discovered by one of the programs ran by NASA that was essentially responsible for scanning different glaciers through radar mapping in order to discover what's underneath. And here the major discovery was a really large crater, a crater formed by a major impact that was smaller than the one that killed the dinosaurs, but still large enough to potentially influence the planet in some extreme way. And because of this actually gave a lot of excitement to this somewhat controversial hypothesis. Or basically it brought it back into view, giving it potential evidence. The idea known as the Younger Dryas Impact Hypothesis. An idea that's actually supported by only a very small minority of scientists, but that in the last few years tried to use a lot of different types of evidence, including different types of deposits, in order to explain the unusual cooling period known as the Younger Dryas. A period that started approximately 12.9 thousand years ago and lasted for approximately 1,000 years, which then led to the sudden end of glaciation and the beginning of the modern Holocene age. But exactly what happened here was always kind of questioned. And although the most accepted and probably the easiest explanation involves a melting of a glacier that basically changed the distribution of water and the currents on the planet, the explanation that always sort of captured attention was the one involving potential impact. An impact that might have occurred approximately 12.9 thousand years ago and could have maybe changed the conditions on the planet just enough to cause the cooling and to possibly even cause an extinction event, because we know that the Younger Dryas also sort of correlates with the major disappearance of megafauna. A lot of different types of animals that used to exist here that eventually perished for some unknown reasons. And though normally in science, the most boring explanation is usually the correct one, in the media that's not really the case. It's really the most spectacular explanation involving the asteroid impact that sort of captured the attention. And so it was actually the discovery of that crater that suddenly gave scientists behind this hypothesis a lot of hope. What if this is exactly what they were looking for many years now? The proof of that collision 12.9 thousand years ago, explaining everything all at once. Although here they had a lot of other evidence as well, for example tiny microspherules, or basically tiny pieces of glass that they believed were produced during such an impact, deposits of platinum that they believed came from outer space, and just overall the layers that they referred to as the black mat that according to the small team of scientists was always dated to have been approximately 12.9 thousand years old. And so by itself this hypothesis appeared to have a lot of evidence, and a lot of people actually sort of, for the lack of better words, bought it. Now, me being me and me being kind of, I guess, boring, I always kind of questioned it from the beginning, and I always wondered, okay, but is it possible that maybe this is actually not the explanation here? And I obviously made a few videos about this, trying to refute the idea. But it wasn't really until recently that I finally found a paper that basically does everything for me. It literally refutes every single point ever made in this hypothesis. And they do a pretty good job at finally putting this to rest. It's extremely unlikely to be an impact, with the younger Dryas just being something entirely different. And so, hello wonderful person, this is Anton. Let's discuss a couple of papers that were recently released, with one definitively disproving the younger Dryas impact hypothesis, and the other possibly presenting an additional explanation to what might have happened to a lot of megafauna around this time. As always, you can find both in the description below. So here, I think the title pretty much explains everything. Comprehensive Refutation of the Younger Dryas Impact Hypothesis, by Vance Halliday and quite a few other scientists. Now this is not the first refutation of this idea, but I think this particular paper probably presents the most comprehensive analysis to date. And well, in a nutshell, they kind of explain that everything that's usually used as a kind of a proof of this hypothesis is always either somewhat misinterpreted or basically completely wrong. For example, let's take this crater. It's known as the Hiawatha Glacier crater, and in theory, it could explain the hypothesis if it did date to this particular age. But turns out that most of the recent analysis suggests that this is actually something like 50 million years old, not 12,000, 50 million. So there's absolutely no way that these are related, suggesting that there is still no crater for the hypothesis, even though a very large crater would be expected. So basically trying to invoke some kind of a cosmic event to explain all of this, at the moment just doesn't really make a lot of sense. No crater, no proof. Okay, let's just keep going. Proponents of this hypothesis would often use a lot of different types of magnetic grains, spherules, nanodiamonds, or even plutonium as a proof of a potential impact. But when many of these studies were re-examined, there was usually a tremendous amount of issues with anything from identification of what exactly we're actually looking at, to quality of measurements, to interpretation of results. So basically just by looking at something, they would assume it's maybe, I don't know, spherule produced by impact, but in reality it could be something entirely different. There was just no proof of any of this in any of the studies. As a matter of fact, many of these particular phenomena were later associated with many terrestrial processes that don't require anything from outer space. No impacts, no asteroids. On top of this, a lot of sites that were originally used as an indicator for this impact did not have a very high precision dating technique used to determine the timeline. In many cases, the quality of the data was just not very good, and some of the samples, or some of the layers, appeared to have way too much uncertainty in terms of the age, up to 1,000 years. So basically dating these samples was not really done very well, or was done in a way where it wasn't clear what the age was. Likewise, one of the main propositions in the hypothesis is the demise of one of the human cultures known as the Clovis culture that used to exist in North America. This was assumed to be the result of the impact. That's of course on top of the demise of the megafauna. But the problem here is, once again, just really no evidence. Too many incorrect assumptions, unusual conclusions, misleading information, and quite a lot of logical fallacies that just don't make any scientific sense. For example, when it comes to the Clovis culture, the hypothesis assumes that they disappeared completely after the impact. But in reality, all of the evidence points at the opposite. It points at some kind of a cultural change in the humans that used to live here, involving technological change and just a general change in the way that people live their lives. A cultural change is a very likely explanation here because that's just a human thing. So basically it was a transition for the clothes into something different. When it comes to the megafauna extinction, the assumption before was that it happened right after the impact. But in reality the evidence suggests the opposite. A lot of the megafauna disappeared way before the impact, thousands of years before. Some others survived for many years after, for example mammoths. So it just doesn't really make sense once again. On top of this, a lot of the locations used to try to prove the hypothesis only usually provide a kind of a age estimate, never really a precise age that would help us with statistical errors and would help us determine the exact point of impact or the exact time of impact. So far, none of this was done in any of the studies. Then there was the question of the black mats, the organic rich soils that were believed to be a result of the impact. But many studies after that basically refuted this, saying that there is really no connection whatsoever. None of them seem to be linked to the younger Dryas period, and only a few examples in maybe some locations seem to have happened in maybe the same millennium. But none of this was probably the result of a collision. Then one of the biggest assumptions scientists behind the hypothesis always state is that somehow younger Dryas represented an extremely unique period that didn't actually happen during the Quaternary for approximately 3 million years. That turns out to be false as well. Apparently quite a few of these similar events happened hundreds of times during the entire Quaternary. So this is not even something that's unique in any way. Scientists behind this paper provide evidence for similar events that happened many times before. The other assumption that's often repeated is that somehow this was an event that happened everywhere on the planet all at once. Basically the temperature changed instantly everywhere. In reality though, this also goes against a lot of the record we have so far from various archaeological digs. It was not instant, it was not synchronous, and it happened at different times in different regions. If this was an impact, that's impossible to explain. Once again, more evidence in that paper I mentioned. Scientists behind this recent study also discovered a lot of badly misinterpreted ice core records that many proponents of the hypothesis used before to try to prove their point. For example, they tried to prove that in the ice cores there are signs of huge amounts of fire around the planet. In reality, the data is basically pointing at the opposite, low incidence of fire. Or at least in the data that they were trying to present. We'll actually discuss the fires in a few seconds. So once again, they just show that the data interpretation in this case was not very good. On top of this, microspherules that sometimes are believed to be a product of an impact, in reality have quite a lot of different origins. And in this paper, they even show that some microspherules used for younger Dryas impact hypothesis in reality are produced by fungi or tiny mushrooms right here on planet Earth. Here's one of the examples from one of the older papers, and it's basically a fungal sclerotium. In other words, what they thought was an impact spherule is just a tiny mushroom. And so there's basically a pattern of similar misinterpretations and misanalysis of so many different things. And so the scientists behind this hypothesis have always been doing this. They basically see something, think it's related to the impact, try to prove it, it turns out to be like a duck or something. And unfortunately, the counter-evidence always gets buried by the amount of excitement these types of discoveries make. And so yeah, most of these are not the result of an impact. They're just a result of life on Earth doing Earth-life things. They also use platinum anomalies as a proof that all of this is extraterrestrial, but in reality, there are quite a lot of terrestrial sources that produce exactly the same observations. But most importantly, there's never really a crater. It has never been found. And without a crater, the only possible evidence they had was the record of fires. Specifically the layers of charcoal that was believed to be the result of some kind of a major fire started by the impact that happened 12.9 thousand years ago. And in this case, the evidence is strong. There might have been fires around certain time during this period. Not necessarily 12.9 thousand years ago, but definitely sometimes during the younger Dryas. multiple peaks of charcoal abundance are quite clear in a lot of different samples, and actually did occur during periods even before the Younger Dryas in separate locations. Here's the thing though, there seems to be no correlation with impacts in this case, but there is a correlation with something else. The arrival of these little guys to certain locations. Which actually takes us to this recent paper that was released just a couple of days ago that potentially explains what may have happened to the large mammals living in North America, at least in one region. Here's that paper. Pre-Younger Dryas megafaunal extirpation at Rancho Brea linked to fire-driven state shift. Okay, let me dissect this for you. Basically, they're talking about a certain area in California where there seems to be a direct connection between human activity, fire, and the disappearance of large mammals, or megafauna, around the same period of time, with the overall correlation being very strong and essentially showing us that approximately 15,000 years ago it might have looked like this, 14,000 years ago things were maybe changing a little bit, but 13,000 years ago things really took a turn for the worst, and it might have been because of fires, which were most likely caused by our ancestors, who basically learned how to produce fire and who might have either accidentally or on purpose started to burn ground, with this graph showing us a very strong correlation. The arrival of the Clovis culture, the tremendous increase in fires in this particular location, and the slow but very dramatic shift of a lot of different megafauna in the area, along with a decrease in the forest cover and just the overall changes in the environment in this area. And unlike a lot of previous papers, the actual dating here is extremely precise. Here, the radiocarbon dating used approximately 170 bones from 7 different types of animals to try to establish a precise timeline for when they started to disappear. And by then comparing this to the data from charcoal records, they produced a very detailed chronobiology showing a direct relationship between climate, vegetation, fire, humans, and megafauna that used to be very common in the region. In essence, showing that the population of these large animals was relatively steady for over 1,000 years between 15,000 and 13.2 thousand years ago. However, there was a sudden decline in population between 13,000 and 12,900 years ago, which based on the charcoal studies, scientists determined was probably due to fires. Although in this case the fires were probably a lot more common because of the previous change in climate where things became warmer and much drier. And so between 13,500 and about 13,200 years ago, the risk of fires dramatically increased. And because our ancestors were using fire and potentially didn't extinguish it at all times, it could have led to dramatic fires in the region at least once in a while. And so their data indicates that there was a dramatic increase in forest fires about 13.5 thousand years ago, way before Younger Dryas started. And though the humans arrived here probably much earlier, maybe even 3,000 years earlier, the animals were doing fine even though the humans were actually hunting them. So it's unlikely that it's the hunting that caused the extinction, but as we've learned from the fires in the last couple of years, it's quite likely were the fires. These can be very quick and very devastating for the entire fauna living in the area. And so the conclusion from this study is that fire is a way that humans can technically have a large impact over an extremely large area, with the overall climatic changes observed in certain regions in California sort of presenting an explanation that no longer requires any impact or any kind of an explanation that's too extraordinary. And more importantly, presenting us with something that technically is happening right now. Because of the overall drying of the forest around the planet, and because of the overall increase in temperatures, unfortunately the chances for the forest fires have dramatically increased in a lot of different locations on the planet once again. For example, at home back in Canada, one of the cities where I used to live for several years, Yellowknife, is basically now struggling with survival when it comes to forest fires. A lot of forests have been burned, a lot of land disappeared, a lot of animals have been killed so far, and there's really no sign of stopping just yet. And as you might have learned in the last few months from a lot of different news sources, forest fires have been pretty much happening everywhere. I'm secretly hoping that this is just a one-off, but yeah, it's not looking very good, huh? Anyway, on that note, Younger Dryas is probably not a result of an impact. At least that's what a lot of studies are saying. And also forest fires are maybe a sign of something bad to come. Let's maybe be careful and let's, avoid another extinction event. Okay, today we're talking about Sahara. There's a reason for that though. It involves a recent study and years of investigation trying to figure out how Sahara Desert changed in the past hundreds of thousands of years. Because even though it kinda looks like this from outer space today, as recently as 9,000 years ago, it was a much greener place. But more importantly, it seems to go through these unusual cycles of green desert with a very predictable pattern. And though it does relate to a kind of a climate change, it's actually a lot more than that. As a matter of fact, these changes in the Sahara Desert are one of the main reasons humanity evolved into what we are today. And so, hello wonderful person, this is Anton. Let's talk about some of these more important findings about Sahara, focusing on the recent study that came out a few days ago, discuss some of the evidence we have in regards to what this used to be like just a few thousand years ago, and talk about where it's headed next in the next few thousands of years. But also basically what drives all of this. Because unlike a lot of other patterns when it comes to climate change, this one is actually quite extreme and quite unusual. But let's start right here. Here's an intriguing several thousand-year-old picture discovered in a cave in Sahara, literally showing people swimming. And so when this picture was originally discovered, it implied that maybe Sahara was not always like this. This is actually a pretty old discovery, but it sort of started this questioning process. Another intriguing picture is what's known as Lake Unyanga. You can kind of see it right here in this image from NASA, but this is literally right in the middle of Sahara. It's actually right here in Chad. And so what's really unusual about these lakes is that they're technically formed by water that used to exist here a long time ago, with a lot of it coming from underground, and a lot of it representing the remnants of water that used to exist here thousands of years ago. But being the hottest and the driest place on Earth, and essentially the largest hot desert on the planet, the biggest desert technically is Antarctica, but that one is obviously a cold desert. Anyway, being the hottest and the biggest, we really don't expect any water, especially in the center. Yet here we are, and there are quite a lot of signs of remnants of water all over the place. Archaeologists even found remnants of hippos in some of the strangest locations in Sahara where nobody knew water existed. And this was once again from approximately 9,000 years ago. With a lot of this preliminary evidence implying that Sahara was probably not really a desert up until recently. But then quite suddenly, in just a few hundred years, it transformed into what it is now. The evidence for this change was pretty strong. But a few decades ago, scientists wanted to find out if this was just a one-time event or if this was some kind of a cycle. And some of the first evidence that this is a cycle came from studying various caves, specifically what's known as speleothems. For example, stalagmites and stalactites. These usually require underground water to grow efficiently, and they often require hundreds and even thousands of years to grow very large. And so kind of like with the tree rings, by studying the growth patterns inside these formations, early studies established that this seemed to be a cycle. Sahara seemed to change every few thousand years, going between desert and a more typical to Africa savanna state with a somewhat predictable rate. But it wasn't actually clear how often. It wasn't clear if it was 40,000 years, 100,000 years, or something entirely different. But what became clear is that this new desert Sahara formed between 8,000 to 6,000 BCE and seemed to coincide with the collapse of the ice sheets in the north. Basically the end of the last glaciation period. And so the assumption for many years was that it was maybe related to glaciation and to the ice ages in general, suggesting that maybe this happens every 41,000 years. But interestingly, the evidence also suggested that Sahara was also dry approximately 13,000 years ago, which didn't really fit the pattern. Basically, during the last glaciation period, it wasn't really green as you would expect it to be, which led to a lot of different propositions. If not ice ages, could it be asteroids? Could it be something related to volcanoes? Maybe some kind of a release of a greenhouse gas? Or is there something else entirely going on here that nobody really considered? And so a few years ago, there was actually a study from the MIT that used the analysis of sedimental deposits, focusing on the isotope of thorium, which is often produced at a constant rate and tends to dissolve in seawater, but usually sinks into the sediment right away, to basically determine how rapidly dust was accumulating on the seafloor, the dust that was coming from Sahara. So essentially, when there is a lot of dust, and a lot of it gets deposited as a sediment, the overall concentration of thorium is usually pretty low. But when a desert shrinks in size, and there's a lot less sediment, and there's a lot less dust being deposited in the water, the concentration of thorium jumps dramatically. And through these patterns, the researchers found that the cycle seems to be almost exactly 21,000 years, and also somewhat correlated to various types of monsoon activity that seem to happen in Africa. And the only explanation here that made sense was that this was related to one of the Milankovitch cycles, specifically the cycle of precession, a slight wobble on the axis of planet Earth that changes the rotation by approximately 2 degrees every 21,000 years. And so when the cycle affects the northern hemisphere, it tends to increase the strength of what's known as the West African monsoon system, which also causes much warmer summers in the north, including Europe and Asia, but most importantly, quite suddenly introduced a lot of precipitation to the entire desert, which apparently very quickly results in the spread of the savanna-type vegetation pretty much across the entire region. Also apparently gives birth to a lot of these unusual creatures currently hiding in the sand. This is an example of what's known as a tadpole shrimp, something you might have also seen from some of the pictures in the 2023 version of the Burning Man. And so in a lot of different deserts, when the rain starts, these unusual creatures come out to breed, hatching rapidly in just a few hours, forming eggs, and then disappearing into the sand until the next rain. Fun fact, that's basically where you also find brine shrimp, also known as the sea monkeys. Quite a lot of deserts out there seem to contain these unusual organisms, basically just waiting for that rain to start. But once the climate changes completely, the entire region transforms as well. And so apart from these little guys, everything starts turning green. And very likely stays this way for thousands and thousands of years. And it seems that every time this happened in Sahara, it's sort of correlated with the major migration of different species across Africa, and most importantly, major waves of migration of humans out of Africa as well. Or just to rephrase this, the entire Sahara acts as a kind of a gate control mechanism for dispersal of various species from North and Sub-Saharan Africa across the entire planet. And when this was originally discovered back in the days, this was a huge breakthrough. It basically helped us understand how humanity evolved in the last few thousands of years, and how all of this led to the spread of humans across the planet. So basically, when Sahara remains a desert for thousands of years, humans, along with other species, tend to be concentrated in the region in the south and of course in Central Africa. But as soon as everything here became green again, that's when the migration started, happening several times during the last few hundreds of thousands of years. But in order to try to understand this even better, some of the recent studies decided to really find out if the cycles here were only driven by the axial changes or if there was any other effect. Turns out that there is definitely something else. And it actually seems to be a combination of things. And by simulating various Milankovitch cycles and also conducting climate simulations involving glaciation periods, focusing on the last 800,000 years, the researchers behind this recent study basically confirmed that it's not just the axial tilt, it also seems to be affected by the actual glaciation as well, discovering that during the glaciation period, when the ice sheets are much bigger, it seemed to suppress the formation of Green Sahara, preventing the humid periods from forming and obviously preventing the migration of the species. But in between glaciation, when the planet warms up and when the ice sheets shrink, the African monsoon system expands and the rains return to Sahara for thousands of years, which basically implies that the actual cycle is not really perfect 21,000 years, and does seem to have occasional pauses here and there. For example, there's a lot of evidence that Sahara was also very green approximately 126,000 years ago, which very likely led to yet another migration period out of African continent. And not just humans, quite a lot of other animals as well. But obviously, it didn't just prevent things from migrating out, it also prevented things from migrating in some sense, allowing a lot of species to evolve in peace in the region that was basically inaccessible to anything else. And because this is most likely where our ancestors came from, by itself, this whole cycle happening in Sahara is a very important part of human history. Interestingly, the next Green Sahara is expected to happen in the next 15,000 years. This is when the North African monsoon season is going to return to North Africa. At least that's what the scientists predict right now, because here we're still learning about these things, and we're still trying to understand what's going to happen to our planet in the next few hundreds of years. But whether humans are still around or not, whoever is around, and whoever is dominating Central and South Africa, is most likely going to get a chance to migrate once again in 15,000 years. The gatekeeping mechanism is going to be once again open. So this is going to be a kind of a climate change video with a bit of a twist. It's not the humans. Hello info person, this is Anton, and today we're going to be discussing a somewhat intriguing discovery that I guess not a lot of people expected in regards to methane. One of the most common and also one of the most potent greenhouse gases. But before we talk about what was discovered in the recent study and what all of this means, I actually wanted to start with a bit of an explanation in regards to planet Earth and the cycles of glaciation. The cycles that basically once in a while create these really large ice sheets, much larger than anything we have right now, covering a large part of the planet. And although normally in the media this is sometimes referred to as the Ice Age, in reality this is still the Ice Age. We're still in it even today. Although a more proper scientific name for this is Quaternary glaciation. Something that began approximately 2.6 million years ago with the appearance of the first glacial period, with many studies focusing on ice cores from Antarctica, establishing a kind of a cooling trend with at least two separate cycles, one being 41,000 years, one being 100,000 years, creating a somewhat repetitive pattern of ice sheet growth followed by decay, with the cycle usually varying between 80,000 and 120,000 years, 100,000 being the average. And from this graph you can actually see that the major glaciation finished approximately 12,000 years ago. But Earth was very likely even hotter than today, roughly around 140 to maybe 130,000 years ago, with the volume of ice even being lower than today. And this last interglacial period is of course super intriguing because that's when essentially a lot of different hominids lived on the planet, with early human ancestors and all of our cousins like Neanderthals and Denisovans coexisting on a slightly different Earth. And unfortunately all of the details of this prehistory has been mostly lost to us because of powerful effects from various glaciers that covered the area that basically erased a lot of the signs of early civilizations. On top of this, many of these civilizations reached their peak when the Earth was extremely different in terms of the levels of the oceans. And assuming that all of these ancient hominids lived in a similar way to modern humans, basically somewhere along the coast very close to the water, they would live on a very different planet. Back then, the Mediterranean was very different. There was not as much water, and the British Isles were more or less connected to Europe. So for example, hominids like Neanderthals potentially existed in these locations, but all of their ancient settlements have been now erased, covered entirely by water. More intriguingly, something similar happened right here in Australia, and there's even evidence from various oral traditions of Australian Aboriginals that actually do suggest that there was quite a lot of people living somewhere right here where there's now ocean. Here the water levels might have been even lower. But these were not just humans, these were all sorts of different hominids, and potentially communicating and trading, or maybe killing each other, competing for territory. With this particular region, Southeast Asia, potentially being extremely interesting, because it didn't have a lot of ice caps, but suddenly had this huge area of land available for everyone to settle. This is actually where unusual hobbit-like creatures, sometimes referred to as the forest men, were originally discovered back in 2003, and potentially thrived here 50 to 60,000 years ago. So this was definitely an intriguing period that, unfortunately, only resulted in one single survivor. Yeah, us. We survived, everyone else seemed to have perished. Now there's definitely signs of DNA from these species in a lot of different cultures around the planet, implying of course that there was a lot of hanky-panky going on, but all of this suddenly ended 12,000 years ago. But what's interesting about this recent cycle is the fact that approximately 6,000 years ago, for some reason Earth stopped warming up and stopped melting the rest of the ice. But this is of course based on orbital modeling, not necessarily samples from Antarctica. And the reason I'm mentioning orbital modeling is because this is generally the most accepted explanation for why we have these interglacial periods. The idea of Milankovitch cycles, slight shifts in orbital parameters of planet Earth that basically affect obliquity, precession, and eccentricity of the planet as it orbits the Sun. And so for roughly around 6,000 years now, humans on Earth sort of got lucky. We suddenly received this relatively stable climate that didn't really change very much, allowing various civilizations on the planet to suddenly explode, developing the culture we have today. Now that's kind of the general assumption. We obviously have no idea exactly what happened, but it's always been believed that Milankovitch cycles sort of affect a lot of things. And luckily for humans, this cycle was predicted to be somewhat moderate, with the next potential glaciation happening maybe in the next 50 to 70,000 years. For example, various sedimental studies determined that the sea levels rose by about 130 meters between 20,000 and 6,000 years ago, but they generally stopped rising afterwards. Here's sort of the graph that shows us how the sea levels changed in the last 20,000 years. But during every one of these cycles, glaciation cycles, if you actually look at the graph, they all had this very strange period known as termination. This graph helps you visualize this a little bit better. They represent these very unusual jumps in temperature, extremely steep jumps in temperature, that definitely occurred several times. And today we know that termination is a major event when it comes to reorganization of Earth's climate system. They very often occur in three separate stages. First stage is a rise in methane and CO2, second stage global warming, usually over a few thousand years, and the last stage, a sharp increase in temperature, normally fueled by a burst of methane that then lasts for several thousand years again. You can read more about these particular events in the study you can find in the description from 2008. And so these termination events, which do take several thousand years, strangely very often have this very sudden stage that lasts only a few decades. It's the last stage that then ends with a major release of methane that increases temperatures even more for thousands of years. And that's also the stage when usually the levels of water rise dramatically, most of the ice melts on the planet, and as you can see from this graph, the planet becomes just a little bit toastier, up to 3 to 4 degrees hotter. And based on various sediments, we know that last time this happened, places like tundra essentially turned tropical and had a tremendous amount of really strange creatures roaming the surface. So for example, things like this: glyptodons, size of a small car, resembling strange mixture between a turtle and an armadillo. We'll be discussing more of them in a video in the future. Make sure to subscribe. But here's the important fact. Even though I'm basically talking about history, or technically prehistory, it actually seems to apply to what's happening right now. And no, I'm not talking about CO2 levels, I'm not talking about anything political, I'm actually talking about something that was recently observed and doesn't really have a good explanation just yet. So here's what the new paper basically found. When it comes to global levels of methane, we know that various human emissions mostly soared in the 80s, but generally stabilized by the 90s. A lot of this was actually due to various regulations, but also various technologies that sort of improved our ability to extract methane without causing a lot of it to be released. And so since then, for several decades, the levels were somewhat constant, which is basically why a lot of people sort of stopped talking about methane as a potential source of warming of planet Earth. But for some reason, something happened in the late 2006. The methane started dramatically rising again, even accelerating its growth, speeding up all of the emissions even higher than they used to be. But that's despite data suggesting that the human emissions most likely decreased. Or at least there was no dramatic shift in human activity anywhere on the planet. So yeah, it wasn't us, I think. At least that's what the scientists think as well. But the question being, so what's happening then? What's going on? Well, first of all, by 2020, it looked like the rise of methane was the fastest ever recorded. And so several studies in the last few years suggested that it's probably coming from various tropical wetlands, most likely in Africa. With previous conclusions suggesting that the wetlands most likely got much bigger because of a previous human-caused climate change, allowing a lot more plants to grow here that now started to decompose, producing huge amounts of methane today. With this basically now being referred to as the wetland hypothesis. And though there's definitely some evidence for this, that was mostly presented in previous studies, there could also be other sources as well: agricultural, biomass burning, waste emissions. For example, here's various contributions from different types of farm animals, basically cow farts. And although it's unclear what exactly the source is yet, what's clear is that it's definitely growing bigger and bigger, but more worryingly, resembling previous emissions from previous termination events. That last stage that would usually last a few decades, resulting in the temperature jumping by several degrees and lasting for several thousand years. And that's the main message from this new study. It hints that we might be in yet another termination event, just like thousands of years ago, that might suddenly transform the planet in mere decades. And though in this case, human activity is maybe not the highest contributor, all of this did start because of human activity previously. And so there's no exact proof just yet, but it's definitely an intriguing proposition. Although here it's also important to remember that It is kind of expected. We do expect Earth to warm up at some point or another. Remember, this is still Ice Age. And because we still have polar ice sheets, we're still technically in the glaciation period that's turning into interglacial period that's supposed to reach a peak sometimes in the future. And though this unusual stability in climate allowed humans to evolve so dramatically, leading to what's known as Neolithic Revolution, establishing human civilization, we don't really know where all of this is headed just yet. But it's not all doom and gloom. First of all, we know that methane, unlike CO2, is not a permanent greenhouse gas. So even though it's technically much more potent, up to 80 times more potent for at least 2 decades, it generally tends to be destroyed by the sun within about 12 years. In other words, if we actually find a way to potentially stop methane emissions right now, reducing the overall levels even higher, a lot of this methane will get disintegrated by solar radiation by mid-2030s. But honestly, at this point, nobody really knows what's going on, other than the observations that it does seem to be happening pretty quick, for reasons still unknown. And with 2023 being the hottest year on the record, yeah, that means that maybe 2024 is going to be even hotter. But we're not going to know much more until future investigations, and so at least for now we're just going to leave it at that. We don't really know what's happening. But if it is a termination event, and if the planet is going to be warming up dramatically for the next few decades, I'm gonna have to buy a bigger fan. Anyway, we'll definitely discuss this in some of the future videos if there are additional explanations or someone actually figures this out. Thank you for watching, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else. Support the channel on Patreon by joining channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.